Sa, vedi,
Sento,
e ti
sì.
arriva. Quindi qui te c'hai. Poi
Hello, everyone, and welcome back to Panino for the last day of PyCon. So sad, right? Now we have a talk from Emangi that it's called From Pydantic V1 to V2. Pydantic 2 release reshaped Python app development. This session explores the benefits and trade-off of Pydantic in Rust, appealing to Python developers keen Python-Rust integration. Welcome.
Hello, everyone. This is truly a fan moment for me because we have the founder of Pydantic sitting here. Thank you so much. I'm Himangi Karchalkar. I work as a senior software engineer at EPAM Systems. So let's get started. If I ask someone in the audience, looking at these two images, what is your first impression? Okay, you're right in some way. Those are the side effects, but I would like to say, let's use these analogy. Like, let's consider Pydantic V1 as the unplanned city and Pydantic P2 as the planned city. So Pydantic V1, normally it grew as an experimental project. Since it was an experimental project, there was ad hoc growth. There was no plan to it. So there were a lot of maintainability changes and people found it very difficult to maintain and use and browse through the source code. Now consider Pydantic V2, the planned city. As you can see, planned city, it has improvised structure, efficiency, and reliability with improved performance, and it is easy to maintain, and it has also introduced in some new features. So the birth of this talk took place when I was actually doing something. I was writing this exact piece of code, and I ran into an error. So basically, you can see here, I have defined two models. One is a Pydantic model, as it inherits from base model, and the other is a ID. And this model has an attribute ID, which is of the type ID, which denotes a UUID. So when I ran this code, I ran into a series of errors. So what happens in a programming language when you hit an error? You get a stack trace. So in my desperate attempt to debug the code, I tried to scrutinize the stack trace. So in the stack trace, two things in particular caught my attention. One, there was a continuous mention to this generate schema.py file along with the path mentioned. And secondly, there was a mention of this function __ get _ Pydantic core schema. Keep in mind these two things because this will be the basis of our talk. So I decided to follow this stack trace and follow the path. So this is what I found out. When I went into my virtual code editor and followed the path in the virtual environment, I could see these two packages, Pydantic and Pydantic core. So I can say Pydantic V2 is a combination of two packages, mainly Pydantic and Pydantic core. So let's start now. We'll take this talk in a way, we'll debunk all the boxes. Now let's start with the left-hand side box, which is Pydantic. So Pydantic is a pure Python package. It translates Python type definitions, that is base model, type dict, and data classes into something known as Pydantic core. I know everybody is confused, so let's get into the details. So going by the definition, it translates Python type definitions, that is base models, type dict, and data classes into Pydantic core schema. So this is a base model, and Pydantic, which is a pure Python package, it translates it into a core schema. So what exactly is core schema? Remember, I said I ran into an error, and there was one particular function that caught my attention, __ get Pydantic _ core schema. So when I searched for this function in the code base, I found it. I found a call to it under this function complete model class, and there were a call to another functions. So this typically looks like if in Django you have used something known as middlewares. That is a call made sequentially to the functions one after other, and something is getting returned. And when I made, when I checked where is the call made to this function complete model class, I found out there was a new method, the constructor the new method is called before the constructor. And in the dunder new method, there was a call to this complete model class. And from this complete model class, there was a call made to this generate schema. From this, there was a call made to the generate inner schema, and so on. Obviously, there were many calls, but these are uh, the main functions that I just wanted to expand on. But still, what is the core schema? It is still unclear. Let's get into it. Since I had this line with me, I decided to print it and see for myself what is this core schema. So it is basically a Python object or a dictionary, you would say, that contains certain information, or you could say metadata. So in this case, you can see it has the type model because A is a model. It has a CLS, the class name, the schema, and again, within the schema, you have again the key type. So you can see a kind of a nesting kind of a structure here. So Rust, it is known that, I don't know for what reasons, but Rust does really well with some nested structures. So now we have like debunked the left side box, like what is there in Pydantic, which is the pure Python package. So it takes your type dicts or Pydantic models and transforms there into a core schema. But where is the validation logic that what Pydantic is known for? So let's explore the next part. So Pydantic core, you can see a crab in snakes, that is Rust in Python. So Pydantic core acts like a Python interface to Rust. So when what I mean by an interface, the dictionary meaning of interface is something that connects two unrelated systems together, a point where two unrelated systems come and communicate. So Pydantic core acts like a Python interface to Rust, means we can use Rust functions from Python by using this library, Pydantic core. And Pydantic core creates a schema validator object from core schema. So we have the core schema, which I explained earlier, which was a Python object, and we supply it to Pydantic core, and you get a schema validator object. So now let's understand what is the schema validator object. You pass this core schema to a Pydantic core library, and you get a schema validator object. So this schema validator object is actually a Rust object. It is not a Python object. And so Pydantic core creates a schema validator object from core schema. If you look at the yellow box, you could see I have passed in the core schema to the schema validator, and you get a schema validator object. And on that object, you're calling the validate methods. So all the validation logic is also in Rust. It is not in Python. So these are the things that are happening under the hood. You don't need to do it yourself. Pydantic is doing it for you. So now let's understand some Rust's not so good parts. So we have a recursive code, and in Rust, we don't get recursion errors very easily. So it becomes very difficult to catch recursion errors. So this is a piece of code that I ran on two different environments, and I got two different errors. Firstly, the main thread has overflowed its stack overflow error. And second is the process didn't exit successfully. If we have some cyclic model in Pydantic, then how would the validators work? The validators would simply crash. Just like here we have a Pydantic model named node, and we have an attribute n, which is again a list of nodes. And behind the scenes, the validator would crash because they would run into some infinite loop. But the core principle of Pydantic is if the validation fails, it gives a validation error. So earlier in Pydantic v1, it was it simply crashed, but in Pydantic v2, we are getting some cyclic errors because a lot of work was done here. So this is something that is not like a smooth process. Secondly, Rust, like any people who are coming from Python, they don't want to get that much verbose. It looks very static and a lot to type, and it is not elegant. Not to highlight the bad parts of Rust, but I love the elegancy and simplicity of Python that Python has. These are the same pieces of code, like equivalent of in the both languages. Third, now let's go over some cool features that I have used over the years. Obviously, there are lots of features, but have just for this talk simplicity, I have mentioned a few of them. So strict mode. So strict mode, what does a strict mode do? A strict mode ensures the data to be validated to conform to the model definitions. So here the data that I'm validating is ID and name. So ID should conform to the model definitions. That is, ID should be an integer and name should be a string. But while the strict mode is on and I'm validating, it will throw an error, which was not the case in Pydantic v1. Also, we have built-in JSON parsing. So we have here in this model, we don't, like in JSON, we don't have something known as tuple. So, but how does it validate? And instead of using Python, like in v1, we were using the JSON module, like json.dumps and json.loads for serialization and deserialization purposes. But in Pydantic, since tuple is not there, it will validate even with an array. But if you validate just the model, you will get an error because you're not allowed to validate with a list. It is a tuple. Thirdly, we have wrap validators. So validators is something before Pydantic does its validation, you get to validate on your own, like custom validators. So wrap validators can run before or after the Pydantic, like they are flexible. You have to configure how do you want to run them. But the major use case of wrap validators is when you want to validate a data, but if the validation fails, you want to return a default value. Like you don't want an error to go. So in this case, you can use the wrap validators. And alias choice. So alias is a different name. Sorry. Alias is a different name for a value or a variable and is used when serializing and deserializing data. In this case, we have a user model, model with the name of user, and we have a first name. And for the first name, we have two choices of alias, that is first name and F name. So we can validate it using we can validate first underscore name using the alias choices, first name and F name. And in the similar way, we can validate the last name using the aliases, last name and L name. But keep in mind, whenever you're using alias choices, you don't get to use the fields that are defined on the model. This will run into an error. You can use the choices that are mentioned in the alias. Again, we have alias path. So as the name says, alias path specifies the direction to a path based on the alias path. So the first name, how do you find the first name in the data to be validated? It says, look for the first name with the key names and at the index position 0. Look for first name with the data, with the field names in the index position 0. So John is going to conform to the first underscore name. In the similar way, last name is going to be Doe. So these are very powerful features. Say we are validating data from third-party sources or there is a lot of nesting. So we can use these features. So now this is my favorite part. These are the use cases which I have personally used Pydantic with. So commonly used known use cases are with Fast API and SQL model. So Fast API, I think everybody is knowing. SQL model is an ORM. Basically an ORM is a library which interacts with the database in a language specific way. So it is a beautiful marriage between SQL Alchemy and Pydantic. Apart from that, to validate function arguments. So in this, I have written a function, extract first character. I will be supplying a string, and I want to return the first character. Keep in mind, it will validate the function arguments only at runtime. For static time, you can use linters. So this is how you do it in Python. If I'm like running this function, I'll check if the parameter that is passed is not none. I'll raise certain errors. If it is not a string, I'll raise an error, and the length should not be equal to 0. This is the way you validate in pure Python. Now let's go to the Pydantic core. The entire 5-6 pieces of line of code is reduced to 1. Firstly, what you do, you import something known as annotated from typing. So what is annotated? Annotated lets you define custom types. In Python, we have types like integer, float. So here, we'll be defining custom types. So I'm defining an custom type named non-empty string, and I'm setting a constraint on it with the minimum length equal to 1. And now here comes the pydantic code. You import a decorator named validate call and put it on the function. And in place of function parameters, you just mention that it is a non-empty string, and it will work. So this is also one more use case wherein pydantic is just not limited to classes. You can also use it in functions independently of the classes. Okay. Also, it is used for consuming a REST API. This is a very small example. So imagine you have an endpoint of users, and there is a method named get, and this is the API response. And this is your user model, and you only want two fields, first name and ID. But here there are many fields. So you can use model config. This key acts like model config, acts like a metadata key. That is, you can you can place your configurations in this key, and you can supply this keyword arguments extra is equal to ignore. And once you do this, it will just read ID and first name. So the output of this will be a model instance of user. We'll create an object of the user. Yeah, before coming or discovering Pydantic, I used to read CSVs or Excels using pandas. And then, working on some non-unknown values using numpys. But do I really need such big libraries when I have to just perform a basic thing of validation? Say I have a CSV file and it has 4 columns: username, identifier, first name, and last name. And I want to validate the data as I'll be using it afterwards. So if you see the identifier, there are commas in the numbers. So I can't use it. So we can use a pydantic function to help with this. So what you do is, again, you construct an annotated type and create a before validator. A before validator will run before pydantic's own validation logic will run. So that the reason I'm using a before validator is because if I use an after validator, anyway, I'll run into an error because pydantic won't consider this commas as an integer. It won't be able to parse it. So what I'll do, I defined an annotated type by the name int transformation, and I configured a before validator, and basically I converted, I removed the commas and made it a number and returned it. And in the similar way, I just read the CSV file using a dict reader and created a generator. And this is how it works. So this will reduce, like you don't need to install pandas, you don't need to install NumPy, and then you don't need to install very heavy libraries just for performing data analysis or some validation. Thank you.
All right. Thank you for the call, the talk. It was really useful. Let me check if there are some questions. Yeah, we have some. One moment. Okay, first, would you suggest to use the SQL model lib even if it isn't a stable version?
Okay. Personally, I have used SQL model in my applications where earlier I was using Django, but Django ORM doesn't work really well with asynchronous calls. So I had to leverage SQL Alchemy, but it is doing pretty fine in production. So I don't know what exact use case are you referring.
Okay. They disappeared.
No questions.
No, they disappeared. Okay. They reappeared. Thank you. Does function call validation work well with static type checkers, mypy, pywrite, or can conflicts arise? MyPy and...
Okay, it works well. I have used it. so you can use it.
Fair enough.
I'll just kind of. Sorry, it should work absolutely fine because the static type checker will understand annotated and effectively ignore everything other than the first argument. So where you have annotated of int, whatever else, field or greater than or before validator or whatever, it will ignore everything else and just think of it as int. So it should just work fine with static type checking.
Thank you. So, last question for now, but if you have more, there is some time still. Is there a boundary between validation and transformation that I can tell?
Yeah, as the name suggests, validation, you are just validating if the number you are inputting in for serialization or deserialization, is it integer or is it a particular type that you have defined. But transformation will coerce, it will transform the data. It will change the data, the input data and the output data, there will be some differences. So that is the boundary.
Any tips to migrate from Pydantic v1 to Pydantic v2 in a big code base?
Yeah, so basically my experience with Pydantic revolves around using and migrating Pydantic v1 to v2 in my own source project. So there is a big documentation guide on the website of Pydantic that is there. And also make sure you are aware of the kind of errors that the library is raising. Because earlier there were different errors and we caught those particular errors and some things broke down in the production.
I can add something if you like.
Yeah, sure.
Okay, sorry to...
No,
We have still 10 minutes, so.
Sorry to interrupt, but we know it's not easy to migrate, and obviously Python has a limitation that you can't install two versions of the same package. So we vendor Pydantic v1 within v2. So from pydantic.v1 import base model, we'll give you v1 base model, so you can use it even when you have v2 installed, and we even have Pydantic v1 as a submodule of Pydantic v1. So the first thing to do is everywhere you import Pydantic, change it to pydantic.v1, then you upgrade to v2, everything should not change, then you can start progressively changing stuff wherever, across your code base.
Thank you. No, one more? You have plenty of questions. Is it possible and actually meaningful to have the whole model defined in an external JSON file including constraints or some validators?
Yes. This is a cool feature of Pydantic where we can generate the model code by using some JSON. So model code generator is a tool and you have the commands on the website and the documentation, and I have personally used. It works really fine, but in any case, we are using some automated tools. There is a slight chance that all the edge cases are not covered. So you may need to sometimes tweak a little bit, but this works really well. From the JSON schema, you can directly generate the model code.
Cool. I can't see any more questions on Slido. Someone in the room wants to ask something that doesn't have maybe access to Slido? No. Thank you very much again. Oh, no, ha alzato la mano.
In beginning your exploration of the Pydantic library to solve your bug, was there anything that would have helped you do it better or move faster or figure out how the architecture worked better?
Yes, because there was not much there was not much documentation on the architecture part. So whatever documentation I could gain was through some of your PyCon talks only. So, but even after watching, so I had to get my hands dirty. So I feel it would be really nice if you could give a documentation, so that helps. Because this, the error that I ran into was a recent bug that was recently closed.
What kind of documentation would have been your preference for the task that you were doing?
Okay, so the current documentation of Pydantic is really nice, and I compare it with Fast API. Like going from understanding, like not everybody is an intermediate learner or an advanced learner, so going from right from the ground level. So even a beginner can understand. That is something that I would prefer.
So I've not used Pydantic, but I've seen it in fast API examples and all they use. But I'm wondering, apart from web dev and those things, can we use Pydantic in like domain code where it's just Python calling Python everywhere?
Yeah.
Use it for general validation there. Does it work well in that use case?
Yes, Pydantic, basically the way I see it is, I started using data classes in Python, and certain functionality was missing, and I had to write a lot of code. So that a lot of code comes like custom validators and all, or you can validate the entire model, which some functionalities are not present in data classes. So you can use it. It works really well. Yeah, sure. No, please, please.
Yeah, I think it's, so I look now quickly. I think Fast API is downloaded 27 million times a month. Pydantic is downloaded 190 million times a month. So the majority of usage is not with Fast API or even with like OpenAI or Anthropic or Docker or any of the other libraries. Most usage is people using it directly to validate, might be CSV data as you showed, might be like JSON data, might be, whatever else. Django Ninja, yeah.
If you want to ask something, just raise your hand. All right.
Excuse me, it's just a follow-up to the previous PyWrite question. So, just to make it clear, what happens is that right now, if I have a function call and I pass, let's say with the example that you had, where the field should be at minimum 1. So if I pass a call with a literal of -3, then my Py will succeed, but then Pydantic will fail at runtime. That's it?
Yes.
Okay.
There is no provision so far. Sorry. So there is no provision right now within Python typing to do like bounds checks, as I think there is in TypeScript. So yeah, there's no way right now to do it. But we have an annotated types package where we specifically define general types for things like greater than, specifically so that in future type checkers can use it, and it's used by hypothesis, for example, to generate strategies for testing. So there's hope in time that those types exist and they're general and they're not specific to Pydantic, so it might happen, but we're not there yet.
Thank you.
We have still 4 minutes. We have still 4 minutes if you want. 3 for a last question. No, last call. Okay. Thank you very much.
Yeah, thank you. Before ending this, I would like to extend a big thank you to Somel, because I went downstairs and he was like, I'll be there at the talk. And thank you so much for attending. It's been a pleasure. Thank you.
with Django and duct tape. You can self-host multiple side projects using nothing but an old Raspberry Pi, your home Wi-Fi, Django, and actual duct tape. I show you, here will show how to get around dynamic IP performance bottlenecks and achieve over 3 nines of uptime while handling thousands of daily requests on a budget of 0 per month. Hanze is a web developer who likes writing Python and surfing waves, creator of Django TUI, Fedidevs, and FlakyTest.dev. Welcome.
Thank you, Luca. And yes, it is true. I host multiple websites, my side project on this little device that you see on my desk here. And yes, I do need duct tape sometimes because this is on my desk and I just sometimes kick it and it falls off. But nevertheless, I still manage to handle quite a bit of load on this little device, even though it's connected through my Wi-Fi network, which also isn't ideal nor optimal. But as you can see here, in the last month, I had 500,000 requests served through this Raspberry Pi. Which I know isn't a lot, but it's also a lot more than 0. And I know most of these requests are not done by humans, they're mostly bots, but you know, robots are people too. So I do sometimes get a little bit of downtime. That's usually when I accidentally hit the Raspberry Pi and it disconnects. But even though I had 7 minutes of downtime back in March, my uptime is still pretty decent. And these are, of course, side projects, so it doesn't really matter that much if the site goes down for a little bit. So what I'm here to tell you today, that this might not be a good idea for your company use cases. Your customers might get upset at you if your site isn't reliable enough. But I'm also here to tell you that it is possible to have a website running in your home, and that it actually can be a lot of fun if you find configuring Linux servers something that's fun. That might be just me, though. So you're probably wondering how to get started with this. What we need at first is, of course, some hardware. Now, I will be talking about Raspberry Pis, but I do want to note that it doesn't actually have to be a Raspberry Pi device. If you have an old laptop or an old PC somewhere just gathering dust, you can always repurpose it and use it as a little Linux server. Now, I like to use a Raspberry Pi instead of an old laptop just because it is very small, it is silent, and it doesn't use a lot of energy. The Raspberry Pi itself is quite cheap. You can get it for like 60 to 70 euros, depending on where you live. And it is quite powerful. It comes with the latest version, the Raspberry Pi 5, comes with a 2.5 gigahertz quad-core CPU and up to 8 gigabytes of RAM. So if you want to get a similar performance from a cloud provider, Hetzner can sell you the virtual machine with this sort of specs for like 7 or 8 euros per month. So if you do the calculation, buying your own hardware is going to pay off in about 10 months. So if you have a project that you want to run for longer than that, it might make sense. So one thing that's very important is that buying the Raspberry Pi itself isn't going to be enough. you're also going to have to figure out the storage situation. SD cards are a good solution for this. The Raspberry Pi has a built-in card reader, and it's the preferred way for you to install the operating system on. You do have to be a little bit careful when selecting your SD card, because different SD cards have very different characteristics as far as performance of reading and writing data is concerned. I made this mistake. I basically, when I was configuring it for the first time, I picked a random SD card that I had lying around, and only years later I figured out that it's actually really, really slow. I only figured that out later because the databases or the data that I was storing there wasn't that much data in the first place. But now that I have a few projects that are where the database size is more than 10 gigabytes, it takes a long time to make backups and to do copy operations. So before buying an SD card, check out some benchmarks online to make sure that you buy a fast one and don't make the same mistake as I did. Now, another thing that you need to be aware of when buying an SD card is that they have a limited the limited number of write and erase cycles. This means that at some point in the future, it will stop writing. Now, it is very difficult to figure out how long this is going to, how long an SD card is going to last for you. But the quotes are between 10,000 and 100,000 write and erase cycles, which can probably last you somewhere between 5 and 30 or more years. If you're unlucky, it's gonna, or if I'm unlucky, my SD card is going to die tomorrow, but hopefully it's going to last for a couple of more years. But this is important, so make sure that you have backups in place, just so that you don't lose any data because of this problem. Speaking of backups, USB drives are great for that. If you remember the first slide, the little stick sticking out of my Raspberry Pi, that's my backup drive. That's where I copy all of the things that I don't want to lose if something goes wrong. And they're fast, they're stable. You can even install the operating system directly on the USB drive, although I don't recommend that, just because the thing sticks out a bit more and it's much easier to accidentally hit and disconnect. I've actually touched the USB drive quite often, and the green chart that we saw at the beginning would be a lot more red if the operating system was on the actual drive. So displays. You don't really need an external display to use your Raspberry Pi. You can always SSH into it if you're familiar with that. If you're not, Raspberry Pi does support up to 2 displays at once. So you can basically configure your whole development environment on it and not need SSH at all. I personally have a small 11-inch display above my other displays. I like displays, so. And it's just a way for me to see what's going on the Raspberry Pi at a given time. It shows me the CPU information, the memory, the network, and which processes are using most of the resources. Here on this graph, I can, just by glancing at it, I can see that there's some CPU usage going on, and that's because of a background task that I have running right now. So I find this super useful. And if you're not familiar, this program that I'm running is called bpytop. It's a Python version of the top program. And I mean, I just like the aesthetics of it, so I'm a big fan. Okay, so hopefully we now have the hardware sorted out. So let's talk a little about the software side on what it takes for us to get a web server running at your home. So the recommended operating system for the Raspberry Pi is named Raspberry Pi OS. I think it was actually called or nicknamed Raspbian at some point, but this is mostly because it is based on the Debian operating system. The latest version is based on Debian 12, Bookworm, and that's, of course, a very solid base for you to start configuring your own things. Debian is also used as the distribution under Ubuntu, so it is quite popular. And because we're all Python developers here, of course I have to have a slide on how to get Python running on your machine. Here, Debian might not be the optimal choice because it does have a few quirks. So you do get Python 3.11 in the official packages, but because of Debian's package policy, you might run into an issue like this one. So Debian has the policy that only one binary can be included in one package, which is bad news for us Pythonistas because we can't live without pip, right? So to fix this, there's another package called Python full, and if you install that, it will make sure all of the dependencies are there. So pip is also going to be available on your system. Now, I personally don't like to be a few versions behind the latest and greatest Python. So what I usually do right after I configure the rest of the system is I go to python.org, download the ARM64 source code, and configure it, do the make install, make test. This sounds complicated, but it's really just a few commands that you need to run, and you have the latest and greatest Python running. Now, I know we haven't configured the web server yet, but I just wanted to give a little example on what we can do with the things that we've talked about so far. So I used to live in Slovenia, and as a surfer, I wanted to surf as much as possible, which means that I was checking the weather forecast for Croatia quite a lot to find the time to go there and surf waves. Unfortunately for me, the right conditions only happen like 5 to 10 times per year, but I was still checking the charts every day because I didn't want to miss that one time where it is actually possible to surf. And this got very depressing very quickly because most of the time the data was just not showing what I wanted it to show. Now I wish I could write a Python script that fixed this and generate the waves for me, but instead I only wrote a little script that checked the data for me, and then if something was up, if there were actually waves coming, it would send me an email like this one here. And sending emails doesn't have to be complicated. You can use a third-party service and you get a nice API or an integration with Django for it. So that's really not that difficult to get going. You just have to get a process that runs once a day and checks some APIs to get this to work. Now, as you can see, the date here is 2022. This is because I actually turned this service off a few years back, but this was only because I found a better solution for this problem, which is the fact that I moved to Portugal. And there's a lot more waves here, so no problem. Okay, but let's actually get a web server running on my machine, because that's why we're all here today, right? So I personally use Nginx to configure as my main web server. There are other options out there. Caddy is one written in Go that's very popular and might even be a little bit more user-friendly. So make sure to check that one out. But I guess I'm already old and I like boarding technology like Nginx. So that's what I use. You basically install it through the package manager, and voila, you have your web server already running. Now here, the IP address, I'm not sure if you can see it because it's kind of small, but it's the internal IP address of the Raspberry Pi in my network, which means that I can access this web server from anywhere around my house. So I have another example for how you can use just the web server without any Python yet, just because I do like simplicity, and it is sometimes you don't really have to have sometimes you don't really have to have Python and Django running to achieve certain things. So as I mentioned, I moved to Portugal, but I now had a different problem. Portugal has so many beaches, and they are all turned slightly differently and have different conditions. So what became the problem was figuring out where to actually go to surf, which is a good problem to have. And there are also beach camps pretty much all across the country, but they're in different, they're all on different websites, and the website of some of those websites have pretty horrible UX. So I just wanted something simple so that I can quickly check the camps that I'm interested in. So the initial version of this app, I was experimenting with Flutter at the time, so I just wanted to create a simple API. And you might think that, okay, to get JSON response from a server somewhere, you probably need Django running and REST framework or Django Ninja. But I didn't have the time to configure all of that, so I basically just I just created an API.json file and put it into the public folder in my Nginx config, and that was my JSON API. The app only needed to read the data, so it worked there. And if I wanted to add an additional camera somewhere around me, I would just SSH into my machine and edit that file there. I did later rewrite this in Django, and this is now a Django app, so that it's a little bit easier to add new things. But to get things started, you might not even need Python sometimes. So we do have our server now running on the Raspberry Pi, but now how do we put it on the internet? And this can be a little bit tricky sometimes, because the way that this all works is at your home, your home has its own IP address, what we call the public IP address. So you need to connect to that. When you connect to that IP address, you're not actually connecting to a specific device on your network. Well, you actually are, but it's not the device that that's the Raspberry Pi by default. It's the router that you get from the ISP, your internet service provider. So what you need to do, you need to tell that router that all requests that are, let's say, HTTP requests are forwarded to your Raspberry Pi. And this is what port forwarding is. So if you go to your router settings, you should have a screen there that lets you manage this sort of thing. And here on this slide, I have the example for my port forwarding settings, where I basically just redirect 3 ports, 22, which is the SSH, the default SSH port, 80, which is the default HTTP port, and 443, which is the HTTPS port, to my Raspberry Pi. So that all of those connections go straight from the router to my device. Now here, I do want to point out that there is a little bit of danger when exposing your device to the internet, because the internet is a wild and dangerous place. Once you do that, you will start seeing bots trying to exploit your server immediately. And here, we Python developers we're a little bit lucky, because not all of, but I would say 90 or 95% of the bots that I've seen, they try to exploit WordPress sites. So if you're not running WordPress, you usually don't have much to fear. As you can see with these requests here on the slide, the bot was trying to access PHP files or files within the VP includes folder, which is just a 404 for my case, because I will never have those files at all. So that's one part. Nginx will make sure that things are secure on that regard. You just have to make sure to keep it up to date. But the other thing is also connecting. So the SSH port that we showed, that is also going to get a lot of hack attempts. You get random connections trying to log in with random usernames and random passwords on random ports. So you do have to make sure that the password that you chose is very secure, or better yet, that you don't use password authentication at all, and instead use public and private keys, which are a lot more secure. So yeah, keep that in mind. But if you take a little bit of precaution, it should be safe. And I think the worst thing that can happen if somebody gets in a hold of your machine is like they're going to probably just start mining Bitcoin or doing some other crazy things on your machine, and then you're going to have to reformat it, and it's going to be a downer. Okay, so when we configure the port forwarding, we now have our website running, and it can be accessed from outside of our network. But telling people to go to your IP address is kind of lame, and people kind of don't want to remember 4 random numbers. So what we need to get is a domain name, and then configure the DNS, the domain name system for that domain, which is basically to say this name, like fedidevs.com, which is going to be an example in a little bit, points to this particular IP address. For this, I personally use Cloudflare. It's a service that provides this for you for free, in addition to some DDoS protection, caching, and some other nice things. So you can, of course, set up your DNS yourself, but the DNS can be quite tricky, so using a third-party service for this is, I think, recommended. And Cloudflare is a good choice. Now, one thing that you will probably run into if you're trying to do this on your home network is that your internet service provider will change your IP address from time to time, because they usually don't give you a static IP address unless you ask really nicely, and even then sometimes they're not happy about it. So in my experience, this only happens rarely, but usually when you go out for vacation and you're not going to be at the house for like 2 weeks or something, which means that you won't even be able to access your Raspberry Pi to figure out what the new address is and fix the settings. And because this happened to me once and I was upset about it, I of course wrote a little helper tool to fix this. I called it Ipster, and it's on my GitHub page. And what it basically does, every minute or so, it does a request to figure out what your public IP address is. It does a request to figure out what the setting in Cloudflare is. And if those two numbers don't match, it updates the Cloudflare setting, so that you might lose connection for about a minute or so, but then your site is going to be back. So this brings us to my third example, which is somehow also has something to do with moving. But in this case, it was me trying to move out of Twitter and to Mastodon, because that's where all the cool people are. So I made a little website that aggregates all the accounts on all the different instances and shows and even aggregates posts for certain conferences, like the PyCon Italia one. And it's Mastodon I'm a big fan of, so it's a pretty cool thing. So I'm going to now explain how I have this thing running on my Raspberry Pi still. I use, so of course, Nginx, but now we're finally going to add Django to the mix. Now, to install Django, you don't have to do anything that special. Django just works on a Raspberry Pi like anywhere else. But if you want to expose it to the internet, you usually add WSGI or ASCII server in between your Python code and the web server. So GUnicorn is a good choice for that if you're old-fashioned like I am. But UVcorn is also a good option if you're trying to do async Django. So this is my config for GUnicorn that I use. The interesting thing here is the bind variable there. It basically tells GUnicorn to create a Unix socket. And this is, instead of using a special port number, we use a socket instead, a file that's basically acts as a socket. And this is just useful because we will never have port collisions if we have multiple things running, and it's an efficient way to host multiple things. I also set the procs name here, which makes it easier to see on my display what's causing the CPU usage. Now, systemd is sort of it had a bit of drama in the past. But for what I use it for, it is pretty straightforward because you basically just create this little file, put it in your systemd folder, and this will ensure that the script that you write here in the exec start part is going to start whenever your Linux starts. And that's useful for services like the G-Unicorn one, because we want to make sure that even if we throw the Raspberry Pi off the table, that when we connect it back up, that it's going to start automatically without needing us to SSH into it. And then once you have that file, you only need to enable it, and that basically makes it so that it will start when Linux starts, and then you can use the start command to start it immediately without rebooting. And now the last piece of the puzzle is telling our Nginx config to basically redirect things to our G-Unicorn process that's now running on our machine. And I know this slide has a little bit of text on it. It's mostly just boilerplate. The two interesting things are the server name directive at the top, that's currently bolded. This tells us which domain this particular set of settings applies to. So this particular one applies to fedidevs.com. And then the location / directive tells us what Nginx should do for this request path. And here we're basically just making sure the headers get proxied over. And the interesting part here is the last lines where we reference the sock file that we created that we mentioned in the G-Unicorn config, and this is basically how we tell Nginx to use it. So HTTPS, yes, it's 2024. You rarely see a website these days that doesn't have HTTPS enabled. So how can you do it? If you want a quick duct tape solution, you can use Cloudflare's flexible SSL encryption mode. This will encrypt the traffic between the user's browser and Cloudflare, which will basically sort of trick the users thinking that everything is secure. But then the traffic between Cloudflare and your server is going to go over, is not going to be encrypted, and it's going to be out in the open. Now this, of course, isn't recommended. Like I said, it's just a quick duct tape solution. So if you want to do it properly, you install a certbot, which is the Let's Encrypt tool, and then they have an integration with Nginx. So you just run this command. It will list all of the domain names that it finds in your config, and you pick the one that you want to configure, and then it will just automatically update all of your Nginx configs and generate the certificates, and everything will just automatically start working. I was actually surprised at how easy this is. And then the only thing you have to do is make sure that this goes, that you keep updating your certificate. So you might want to do a cron job that runs this command from time to time. Okay, now that we have the website running and it's secure, we probably also want to have a way to store the data. So the easiest way to do this is just to use SQLite. SQLite is a very good database for this particular use case. For simple websites, I don't think you're going to find a better solution. And it can scale surprisingly well, maybe better than we might think. It might require some tweaking and some little changes to the configuration of it. And I have a whole other talk on this topic that I will be presenting at DjangoCon Europe. So if you want, you can also ask me about it. But since we don't have too much time, I won't go into too many details here. I will mention that for doing backups with SQLite, make sure that you use the .backup command and not just copy-paste the SQLite file manually, just because you might get a corrupt database if you do the copy commands manually. Postgres is also a good option, and you can install it easily on your Raspberry Pi using the package manager. And again, we don't have too much time to go into the details here, but I did want to include the pgdump command to make sure that you do your backups. And finally, how do I do deployments? So we have the website running. How do I update it? I use GitHub Actions, but really this is the real duct tape of this talk. I have an GitHub action that can SSH into my Raspberry Pi, and then it just runs the following commands. It does a git pull. It installs any new requirements if I added something new. It does the manage.py commands that Django likes to do. And in the end, it restarts the gunicorn process and any worker processes that I might have. So it's, yeah, I think this is the main duct tape of the talk. And it works pretty well. I haven't had many issues with it so far. The way that I restart gunicorn is interesting. So if anyone has, if anyone's interested, I'm happy to have a brand new talk on just that topic. So in summary, what you need to do if you want to have your website running on a Raspberry Pi, you first get a Raspberry Pi and a fast SD card. You install the operating system, you get Nginx, gunicorn, systemd to make sure the services are running. Use SQLite for storage and GitHub Actions to do the actual deployments. And that's it from my part. If you have questions, feel free to tag me on social media. All the links and some resources are on this QR code. And the website that opens up is, of course, also hosted on a Raspberry Pi. Thank you.
Okay, we have a lot of questions.
Oh.
Really. So, starting with, how do you deal with power shortage? How much power does Raspberry Pi need to run? Can power bank sustain it for some time? General question about power shortage.
Yes. So I don't deal with it at all. If my apartment is out of power, it doesn't have internet, so it is not, the sites are not going to be available in any case. So I don't do that, but if you do want to have your Raspberry Pi running, even if there's no power, Raspberry Pi really doesn't need a lot of energy, so you can just get a small battery for it, and it will sustain it for hours. But yeah, I personally haven't had the need to do that.
Do you have to deal with DDoS attacks or any other attack? Isn't it a little bit scary to expose your network? How can you mitigate these issues?
Yes, an excellent question. I don't, or at least I haven't had to deal with that because Cloudflare has protection for this. So I never expose my IP address directly. So all the internet traffic goes through Cloudflare first. And I do have, so I don't really have to deal with this at all. I do get some reports from time to time, and I see that Cloudflare does say that they prevented this and this many attacks, but that traffic usually never reaches my Raspberry Pi at all, so I don't have to care about it. But it is an important issue. Do make sure that you have something like Cloudflare running between your devices just to make sure you're safe.
How often do you back up your files? Is there any unfortunate hour lesson you learned while hosting your projects?
I have automated backup jobs running pretty much every night. So if something really bad happens, I would probably lose maybe 1 day of data, which is not that big of a deal for me. And no, I don't. I guess I was lucky so far, and I've never really had to restore any backups, at least not on the Raspberry Pi. So yeah, I guess I was just lucky so far, but that doesn't mean that you shouldn't be prepared.
And do crawlers respect robots.txt?
No, they don't.
Fair. Did you try to using pyenv to have the Python version that you want compiled and installed, even more than one at once and different ones per project?
Yeah, I actually use pyenv on this laptop, but for the Raspberry Pi, I usually just use the one that's there. That does make it a little bit annoying because I have multiple projects running. I have to update all of them to make sure they work on the latest version. But the recent Python versions weren't that difficult to update, and the projects that I have running, they don't have a lot of source code. They're side projects, so not like what you're used to at your day job with 100,000 lines of code and too many issues to deal with. So it really isn't that much of a problem. But yeah, I do like pyenv. It's a cool tool.
What book, blog, report, etc. would you suggest to someone new to self-hosting?
Sorry, what kind of a
book for self-hosting in general?
I have no idea. I really don't know. There are a lot of blog posts on this topic on the internet, but I don't think I'm aware of a book on this subject. If somebody knows it, please shout it out and I'll add it. Sorry? I guess I'm going to have to write one.
What about having SSH on another port for security and avoid requests to it?
It is an option. I don't think it's. I mean, it's sort of a bit like security through obscurity. You might get less requests, but somebody might still find that port number that you're using. So they might still be able to try to exploit your server. So if you're really paranoid, that is an option, and do it. It's actually super easy to do since you have to configure port forwarding on your router anyway, so you can just do that on that level. The reason why I don't do it is because I'm lazy and I just don't like the fact that you need to then specify the port number in your SSH config. But like I said, if you're paranoid about security, that's also one step that you can take. Do know that it's much more important to use a good password or an SSH key to protect yourself. This alone won't help that much.
How do you send emails? Do you use a cloud SMTP service or do you send emails directly from the Pi? Do they always deliver?
Yes, I use a cloud SMTP server. I have run my own SMTP servers for a long time, and I don't recommend it. It's just too much of a hassle because of spam filters and all of that. So yeah, I think here it's just best to use a cloud provider for it. It is always a little bit tricky, even if you're sending like 1 email per day or 5 emails per year, like for my Wave Watcher project, I did still get the issue that it sometimes went into spam. So there's a lot of little things that you have to tweak to make sure the emails are delivered well. And that's probably a whole nother talk in itself.
Do you think we can set up a VPN server on Raspberry Pi with a setup similar to yours?
Yeah, I think you can do that. I think there's even very popular Raspberry Pi projects. I think Pi-hole might be one. I haven't done that myself. Yeah, Pi-hole. So you basically just install that software and you have a little VPN running that you can use. It's super, super cool, I'm told.
Last question. Would Docker enhance the security?
I don't. Well, that's a good question. It won't make it impenetrable, but it might help prevent contamination from one process to another. So there is a little bit of security benefit from it, but I wouldn't base my security policy just on using Docker. There are also, as far as I'm aware, there are also exploits that can escape the Docker environment and still do nasty things around your computer. But I'm not that up to date on this because I prefer to not use Docker in this on my Raspberry Pi just because of the resource constraints and the simplicity of it all. It's just like another tool and another set of things that you need to be managing, and I like to keep my life as simple as possible.
All right. Thank you very much.
Thank you.
Melin with his talk is Django 5.0, Elevating Experiences with Server-Sent Events, a journey from polling to real-time vibe. Navigate the transition from transitional polling to real-time functionality with Django SSE in version 5. This presentation reveals the seamless integration of real-time features, maintaining the structural integrity of applications. We leverage async Django's features. So Malin is a lifelong software tinkerer and seasoned engineer who typically responds with "it depends" to complex challenges. A perpetual student, particularly fascinated by the history of software and the complexity of human migration. Thank you.
Thank you, Luca. Hello, everyone. Exciting. It's the last day of the conference. So many good talks, excellent keynotes, and I'm happy to introduce you to elevating experiences with service and events in Django 5.0. So let's get started. So who am I? I'm Elhin. I've been a software engineer for a decade, mostly fumbling at building softwares. I work at Chimondis. I'm an engineer and I lead a team of engineers. Chimondis is a marketplace for chemicals. I have a lot of projects on GitHub that are incomplete. So, and if you want to see those projects, this is my handle. Let me start with some caveats. I'm a first-time speaker, so I'm bound to make mistakes. I'll show you a lot of code. That is how I would like to explain what is going on. The last time I got recorded on camera was a slow-moving car crash. I hope it doesn't happen this time. And I'm also easily distracted, so I hope I don't go on a tangent. So, Django. I'm going to do this a little more, but how many of you use Django? All right. How many of you use async Django? And how many of you have used other frameworks like FastAPI or Lightstar or Starlet? All right. So let's cover our bases. I'll quickly go into some kind of definitions. And the first thing that I want to talk about is polling. Simple, old school. Client repeatedly asks in interval to the server. It's like a little kid asking, are we there yet? Are we there yet? Are we there yet? And there are two things, the short polling and long polling that we have. How many of you still use polling? Okay. The next one is WebSockets. It's bidirection between client and server. The message flows in both the directions. It's done over TCP. It's not part of the normal HTTP flow. And the next one is server-sent events. It's a unidirectional over a single HTTP connection. And the client establishes the connection. The server holds the connection and sends back data. Has anyone used server-sent events? All right. So quick look at how the stream format looks like, right? So by definition, an event stream is a simple stream of text messages that is UTF-8 encoded. And the messages are separated by a pair of new lines. So that is basically /n/n. There's also something in the format that has a representation where you have a colon, and the colon is a part for the command. Let's take a look at it, right? So this is how a normal event looks like. And you could see that whenever there's a /n/n, the message is sent back from the server to the client. And the colon is, as you see over here, it's just a data is set as a comment. There is another type of event, and that event is known as a named event. And it looks something like this. So here, you could see that the event has a name, and the data is just another UTF-8 text. This is really useful because you could have multiple events on the same connection. let's jump right in, right? I'm going to go show you some code as a simple one. So this is a simple counter streaming example. All it does is sleeps for a second, counts, sends the data. Let's take it apart. So you're able to see, yeah, okay, that's good. So you see the highlighted part? The highlighted part is the async generator. And what it does, it's the main core, right? So it basically sleeps for a second, it increments the count, and yields the count. And this is how the event data is basically formed. So event data has a name new and also has the count as the data. Now let's look at another component. And this is the streaming HTTP response. Streaming HTTP response has been around in Django for a while, right? And streaming HTTP response in the sync world holds the connection, holds the worker, sends back data. And you usually use this for sending large CSVs, Excel files, and things like that. In the async, that's the sync. So basically in the WSGI, in the async side of things, it uses the event loop. So you can basically have multiple of these without holding up workers. Disconnection. So this is partly why my talk was saying Django 5.0, because disconnection has been handled properly from 5.0. I think from 4.2, if I'm not mistaken, the streaming thing had the async stuff, but the disconnection was a bit tricky. I also had an initial version of the code which said to do fix when 5.0 gets released. And in the discussion, disconnection is basically the place to have cleanup code. So normally, when you have client-dependent disconnection, there's always a chance for failure, right? Because when you close a tab or close a browser, for instance, you're not exactly notified that this is closed. So with this one, you can actually expect this error and then do the cleanup accordingly. How do you develop this on local? So this is a little interesting. In my experiments with async and streaming HTTP, I found that it's easier to do using UVCon rather than the run server, because the run server was getting stuck. It basically took in all the streaming responses and didn't respond. You could actually make the run server work if you have installed Daphne. So, because by default, Daphne had that. So that just works out of the box. A few things to note over here. So you could see a reload and timeout graceful shutdown. Now, this is important when you're doing it in your local, because otherwise your experience of developing local gets worse, especially the timeout graceful shutdown. Because as you realize that the HTTP connections are held, they are not released. So the server doesn't reload. So this is just a small hack to do that. I'm not good at doing live demos. So I'm going to just show some screenshots of how it looks like. So this is the server logs, right? The same streaming HTTP sleep counter. And this is the client. And as you can see, right, you don't need to do anything fancy over here. It's just a curl command on top, if you can see that, yeah. And you see the server events and also the logs on the client. Why are we embarking on this journey? I'm going to sound a little product over here, but our primary focus revolves around delivering substantial value. We select standard frameworks that have a good ecosystem, that have also a good community behind it, is pretty stable, not just in production, but also the framework itself, and also has a decent upgrade history. And Django has been around for close to 20 years or something like that, has a solid ecosystem, has third-party libraries, is battle-tested, and is also robust. But there's another there's another thing also. I got an inspiration from one of the keynotes. It's about exploration. So when you don't have, when you've never tried async Django, this is actually a good opportunity to give it a try because you also get something out of it. I want to stress another important point. If you would like to also understand some async concepts in detail, look at Django's code. Django's evolution of how do you implement a predominantly sync framework to an async framework is a very interesting choice. And I also heard in another talk that it's actually more progressive than saying, hey, let's stop shop, let's switch everything to async and then build the new cool features, but rather giving more and more value as we move to new things. Now, real-time interactions, as everyone know, right, it's basically enriches the modern web application experience. It just depends on what app you're building or what applications in general need this kind of experience. Some of the examples in general where real-time functionality is useful is, of course, messaging apps, collaborative tools, live streaming platforms, online gaming, and of course, real-time dashboards. But a lot of our applications are not exactly falling into these categories, but still can do with some kind of real-time. And that's where we can use notifications, right? Very useful, common pattern to understand. You get new updates for refresh. And it also makes it a little more easier to offload heavy workloads on like a salary task or something like that and keep getting updates of what is happening over there. Now, how do you do that? In a typical scenario, let's say you have your sync app that is running on production, has been running on production for years. And what you do is you basically keep the synchronous app running as it is, because you've also heard in other talk about the DRF not being async friendly, and there are so many things in the components that are still not completely async friendly. That is not on the framework side, but predominantly on the third-party modules that we use. Then you add listeners to the interactions. So wherever you need to notify the users, you basically add some kind of listener. You publish this to a common channel. I'll come to what a common channel is. And then you run your application asynchronously in a different app, which basically listens to this common channel. There is a really interesting talk about this concept by Carlton. I will point the links towards the end of my talk. And how does this look like? I'll just try to represent this pictorially, however I can. So this is your normal application, right? Your sync app has been running for years. You add now the async application. So you can also make, if you're running this separately, you can also make of the existing authentication. You don't have to add anything else. Then you have the server streamed event connection. So when the client connects, it goes to the async app, and the async app then listens on a stream, right? So this loop is complete. Now, when you have something on your sync, your async app listens and sends it back. So predominantly, this is an exploration. So I believe this is something that we can try out without disrupting our synchronous app. I'm going to give another talk in DjangoCon about streaming. So I'm basically evangelizing streaming to see if we can use it. And in that talk, I'm going to explain this a little more in detail. But over here, let's take another example. Anze stored my thunder. I wanted to talk a little bit about Fediverse, but he has already mentioned it. But how many of you have heard of Fediverse? how many of you are on Mastodon? Yeah. So Mastodon is a cool place to hang out. A lot of interesting people in Python and the Django community. So let's take an example of using something like that, right? So let's consume a Mastodon stream, update the process, let's consume the Mastodon stream updates, let's process them, and then redistribute them in real time. Let's break this down again in steps. Stream consumption, right? Collect Mastodon stream updates like how we used to collect tweets in the olden days via sync app. Let's parse the update, store it in a different structure, and distribute them. So this is how it would look like. Again, I'm just trying to do it in a diagram, predominantly same way. And here we are looking at Redis as the common channel. Now, why do we select Redis as a common channel, right? Redis is predominantly always deployed along with the other applications that we have. So it is readily available. You don't have to use another infrastructure. Redis also has a lot of data structures that we can actually support. And one of those Redis data structure that I want to talk about is Redis streams. Very interesting. Released in 5.0, can be used for different kind of topics like event sourcing, log collection, and also notifications. And how would that look like? You can listen to multiple streams, not just one. So you can listen to a post stream, and then you can listen to a user stream. And then you can just have one listener. So it doesn't have to be just two streams. You can listen to multiple streams, and then the listener can decide which combination it should listen to. So in this case, it's just a post and a user stream. Let's look at how the code looks like. So this is listening streams together. It's predominantly this simple. The last ID returned is something that we have to store, but after that, on any stream, any message comes in, this method just gives it back. How does the view look like? You're able to see it? Yeah, okay. Let's take it apart again. So, as I said, user connection stream, right? So you're basically sending the status that someone is online. And then the next part is where you are listening to the multiple streams, right? So it's just a while true loop, nothing fancy. And based on which stream, you can actually form different events. So in this case, I've given an event status and an event new notification just to differentiate between them. Based on that, your client can react. And you can also send heartbeat messages. And this is very important because this is some of the load balancers disconnect the connection when there's idle. So it's always good to send a heartbeat. You can also build different functionalities on top of it, like putting it in like on an online user counter or something like that, yeah? And on disconnection, you just send an event of disconnection. And this is also a place to clean up, I don't know, Redis connections or things like that. At the front end, even though I wanted to do it completely HTMX style, let me just explain in detail why I didn't do that. Here, you could still see there is a small HTMX process over there. But in general, it's very simple. It's just an event source on the JavaScript side where you connect to a stream. It automatically also reconnects, right? And with credentials, you could also just pass on your cookies. So that's great. And then you can add listeners. So in this case, there's a new notification. You just react to a new notification. Please don't judge my JavaScript code. It's not that good. But and then finally, what we do is you take something from the event, and then you call another endpoint. If your connections maintain state, so in the case of notifications, yes, your connections maintain state in the sense you would always maintain whether user has read a particular notification or not. In that case, you can just use HTMX as it is. This is that simple. Now, why not just use WebSockets? Now, a lot of times you don't need bidirectional communication. Most of the times you need some kind of notifications. And you also need to change something in your infra. You have to, if you're set up Nginx for WebSockets, you know that there's always some tweaking going on. Your load balancers might not support the protocol. Compression is not supported out of the box. There's a very interesting talk about this whole thing about SSE, WebSockets, and long polling by Martin. It's in YouTube. It's really interesting. It also talks about HTTP2 and multiplexing and all those kind of things. Now, is it really rosy? Unfortunately not. Also, it depends. But there are some caveats. So one of the caveats is your settings file have been around for a long time. So there's so much of settings depth in it, and you'll have to basically clear them up. Middlewares. There are Django middlewares and third-party middlewares, and some of them are not async yet. So you'll have to look at how you want to do that. The install apps, your own apps at some moment are not really, so as I said before, right, we're running both in parallel. So you're not changing a lot of those core things. And the final one is a connection limitation. So SSE browsers implement this limitations of having 6 connections or something like that. You will have to get over this somehow. If your users are bound to open like 10 tabs of your application, but if it's just a mobile application or something like that, it's not usually an issue. But you could get over something like using the core native JavaScript functionalities like broadcast. A little bit about middlewares. If you want to know how this is implemented, please look at Django again, because Django has actually shown us how you can actually convert a sync middleware to another one. It's fairly straightforward and really interesting, and it mainly uses thread pool executors. I think there was also a talk about async.io where this was mentioned, and I found it really interesting how thread pool executor in general is used. So, if you take away anything from the talk, server-sent events, Redis streams, and of course, Fediverse. I did some small performance stats. Take it with a grain of salt. I ran a render instance, a free one of 512 MB, very little CPU, and the timer one gave me like 500 connections, and the stream connection with the whole Redis gave me like 150 to 200. Still, as just a reference, again, we are exploring. We have not explored, we have not deployed this on production and saying it, but yeah. That's it.
Thank you very much. Okay, we have a few questions. Actually, a lot. So, first one. How do you deal... No, one moment. Okay. What are the pros and cons of servers, events versus WebSockets? The talk that I mentioned before, one of the things with WebSockets is always about tweaking your infra, but still it could be useful in different cases like bidirectional communication, but otherwise server-sent is just predominantly based on HTTP, and you can also use HTTP2 functionality like multiplexing and things like that. I don't know if I answered the question. Yeah. In long polling, the server holds the connection, but eventually needs to close it, and client needs to poll again.
Yeah.
Is this not required in server streams?
No. You can do that. You can just hold the connection.
Cool. How do you deal with the license change of Redis?
Interesting question. So I was also recently, when I was proposing this talk, at that time I think the license change didn't happen. But on a later stage, it happened. And I think I tried out Dragonfly. You could also look at that. Because at the end of the day, there are so many different Redis alternatives that are coming in. But they all implement the Redis protocol. So you don't even have to change your library. You can just directly use Redis Pi and connect.
What's the difference between SSE and WebSockets in the point of view of the load balancer?
I think in the load balancer, if I remember from AWS, the ELBs were not supporting it because it didn't allow it, but the ALBs do it. And there are some load balancers with some tweaking because it's not the normal HTTP flow. It's a little different.
Right. What's the easiest auth method for SSE in your opinion? JWT, cookie, should we use the same as in the sync app?
Sorry, is it the authentication?
3 questions in one. What's the easiest auth method?
Yeah, okay. So what I tried, I can tell you what I tried. What I tried is to use the same Django's session cookies. Because the event source, if you've seen that, wait, let me just quickly show you. Yeah, here. You see the with credentials, it just passes the cookies. So you don't even have to implement any other changes on your authentication side.
All right. Any other question from the room? Okay, I have another one on Slido. One moment. What about synchronous DB access? Is it a limitation?
No, I mean, the ORM, the recent versions of the ORM have all async versions. So you get a filter and stuff like that. So you could just use it as it is.
All right. Someone? We still have 5 minutes. All right. Thank you.
Thank you.
How are you? Questo talk sarà in italiano, quindi non spaventatevi se... qui con noi c'è Giuna Salviati che negli anni veramente ci ha affascinato con ogni suo talk, si scopre qualcosa di nuovo sia a livello di tecnologia sia a livello di piccole chicche, di giochi anche matematici, logici. Lei è una sviluppatrice da tempi... da tempi che nessuno sa, fin da piccolissima ha iniziato a programmare, quindi complimenti anche per la carriera. Oggi, con questo titolo molto affascinante, Infiniti mondi da set finiti di tessere, un approccio quantum all'arte generativa. Io direi che ti lascio la parola, così iniziamo a scoprire qualcosa di questo talk che sappiamo già sarà super interessante. Un applauso da Giuna.
Grazie Stefania, grazie a tutti. Il soggetto di questo talk è un po' particolare, ruota attorno all'idea di implementare un semplice algoritmo per la generazione di mappe e più in particolare di mondi di emoji, come quello che vedete in questa slide iniziale. E come al solito le cose che sono partite in maniera abbastanza semplice e molto algoritmica, in realtà poi si sono sviluppate tantissimo, come vedrete, tanto da arrivare anche a introdurre temi di quantum computing. Ok, allora prima di iniziare io come al solito faccio un po' di presentazioni per chi non mi conosce già. Io sono Giuna Salviati, sono co-leader del Google Developer Group di Roma, sono una VTM Ambassador e una Microsoft MVP. Nella vita sono un solution architect, però in realtà una volta che ho finito di lavorare mi piace insomma ricominciare a lavorare su altre cose, tra cui appunto magari lo studio di algoritmi. Quello che vedrete oggi è un po' il frutto di questi studi che faccio nel tempo libero. Se vi piace l'idea di tenervi in contatto con me potete farlo sia attraverso Twitter, quello è il mio handle di Twitter, One Little Indian, oppure consultando il mio Medium blog su cui pubblico un po' poi tutti i risultati di questi esperimenti. Ok, allora l'algoritmo che vedremo oggi ha per l'appunto come obiettivo quello di generare dei mondi fatti di emoji che siano costruiti soddisfacendo determinati criteri e quindi partendo ad esempio da una mappa di esempio. In particolare noi cercheremo di applicare questo algoritmo alla mappa di esempio in slide. In questa mappa che è molto estiva c'è il mare, la spiaggia con gli ombrelloni e la foresta, insomma tutto rimanda a un'isola tropicale e il momento dell'anno insomma probabilmente invita anche alla generazione di questo tipo di mappe come dicevamo prima. Chiaramente non deve essere possibile trovare un ombrellone del mare, o almeno ce l'auguriamo, perché altrimenti è successo qualcosa di terribilmente storto, ma quello che deve succedere, almeno a prima vista, è che il mare deve sempre confinare con la costa, la terra può confinare solamente con la costa e non può toccare direttamente il mare, e poi la costa invece deve andarsi a trovare tra il mare e la terra. E la costa qui è simboleggiata dagli ombrelloni, il mare dà l'emoji del mare e la terra dà l'emoji delle palme. Quello che abbiamo per le mani quindi in realtà è un cosiddetto problema di soddisfacimento dei vincoli, quello che in inglese normalmente viene detto Constraint Satisfaction Problem, oppure abbreviato CSP, cioè un problema in cui cerchiamo di soddisfare contemporaneamente per l'appunto una serie di vincoli. Questo tipo di problemi magari vi potrà sembrare molto settoriale o molto specializzato, ma in realtà ce l'avete sotto gli occhi tutti i giorni se pensate ad esempio al Sudoku. In questo caso i vincoli che avete ad esempio sono quello di riempire un sottoblocco con tutti i numeri distinti da 1 a 9. Altri ambiti in cui potreste incappare in questo genere di problemi sono i problemi di assegnazione di risorse, quindi ad esempio di allocazione di un budget, oppure se vi siete sposati e avete avuto il problema di mettere 2 persone che non si sopportavano allo stesso tavolo, piuttosto che no, anche quello è un ambito che rientra in questo tipo di problemi. Uno degli algoritmi più interessanti che ho trovato in questo ambito è questo algoritmo che si chiama Wave Function Collapse. Si tratta di un algoritmo che è chiaramente ispirato ad alcuni concetti della meccanica quantistica, perché secondo questo algoritmo, che serve per generare delle bitmap di immagini, insomma, delle immagini, ogni pixel di cui è costituita la bitmap all'inizio si trova in tutti gli stati possibili contemporaneamente, quindi vi va un po' a richiamare il concetto di superposition quantistico. A ogni step poi viene osservato, cioè collassato un pixel, quindi si sceglie il valore di un pixel, anche qui con un'analogia che è abbastanza forte con con l'ambito quantum, e poi l'effetto di questa scelta viene propagato a tutti i pixel vicini, e questo viene ripetuto finché non si sono scelti dei valori univoci per tutti i pixel che sono sulla bitmap. E questo algoritmo in realtà non è un'idea veramente totalmente innovativa, perché riprende un po' un algoritmo che era stato sviluppato precedentemente da Paul Melrell e che si chiama Model Synthesis, e se siete curiosi di vederlo, insomma, c'è il link in questa slide. Adesso l'implementazione di quel function collapse in realtà è parecchio complicata e probabilmente anche abbastanza overkill per andare a generare un mondo di emoji, quindi ci possiamo accontentare di semplificarla un pochino, e in particolare invece di considerare tutti i pixel possiamo andare a considerare delle tessere che nel nostro caso insomma sono le singole emoji di terra, costa e mare. E allora vediamo nel dettaglio come funziona l'algoritmo su questo piccolissimo mondo 2x2. All'inizio le celle si trovano in tutti gli stati contemporaneamente e quindi assumono virtualmente tutti i valori possibili. Poi andiamo a scegliere una cella facendo riferimento a una particolare misura che è l'entropia di Shannon. Intuitivamente diciamo, questa misura ci dice quanti sono ancora gli stati disponibili che possiamo scegliere per quella cella, quindi sarà un valore che sarà tanto più alto quanti più sono ancora gli stati che sono disponibili per la nostra scelta. E ad esempio qui in maniera totalmente casuale, perché chiaramente non possiamo fare preferenze dal momento che sono 3 per tutte le celle, andiamo a scegliere la cella 1,1 e possiamo decidere di porre il suo valore a terra, quindi di metterci una palma. Il fatto di aver scelto una terra in 1,1 ci fa mettere per forza una terra anche in 0,1, perché è l'unica cosa che può soddisfare, diciamo, il vincolo verso l'alto. E dal momento che l'unica cosa che può confinare con una terra a sinistra è una spiaggia o un'altra terra, quindi una costa o un'altra terra, escludiamo automaticamente da quelle due celle, dalla 0,0 e dalla 1,0, il mare. Possiamo anche ripetere questo processo scegliendo una nuova cella da osservare, anzi lo dobbiamo ripetere per portare a termine l'algoritmo, quindi scegliamo di mettere una costa in 1,0. Questa scelta in realtà ci induce di scegliere terra in 0,0 e la mappa che otteniamo quindi è quella che vedete in questa slide e, se ci fate caso, è coerente con le regole che avevamo dedotto dalla mappa di esempio. In realtà, diciamo, questa volta non vi porto i sorgenti, vi lascio solamente il link, ve li potete andare a vedere sul mio GitHub, però quello che mi interessa fare è fare, diciamo, dei ragionamenti su come opera l'algoritmo e alcune cose che possiamo osservare, diciamo, intorno alla sua esecuzione. Ad esempio, quello che viene fuori se animiamo l'algoritmo e mettiamo ogni iterazione su una GIF animata è questa cosa qua. Si vedono gli effetti delle scelte e delle propagazioni e si vede che in realtà questo algoritmo è efficace perché vi popola grandi porzioni di mappe tramite le deduzioni, diciamo, sulle regole, tutte in una volta. Poi vi faccio vedere alcuni esempi di output. I primi 3 esempi sono proprio mondi di emoji. Quindi sono mondi di emoji che soddisfano le regole che ci eravamo dati all'inizio e che sono ottenuti applicando questo algoritmo. In realtà questa è l'applicazione forse più semplice che potete trovare con le emoji, ma giocando un pochino con le tessere potete ottenere dei risultati che sono anche migliori, perché ad esempio partendo dalle tessere che vedete lì a sinistra potete ottenere questo risultato che è molto simpatico, stile 8-bit a tema, diciamo, natalizio. Potete giocare ancora, cambiare tema, avere un tema più primaverile. Qua ci sono gli ombrelloni, gli stagni, eccetera, eccetera. E questo invece è un risultato che ho ottenuto con quelle tessere lì per Halloween. Quindi diciamo, ci sono tutti i temi che sono tipici del folklore di quel momento dell'anno, quindi i gatti neri, i fantasmi, eccetera, eccetera. Adesso un aspetto che secondo me è molto interessante e che è legato a questo algoritmo è quello del di poter controllare la bontà di quello che stiamo facendo, quindi dei risultati che stiamo ottenendo. Quindi la domanda che mi sono fatta io nello specifico era come potevo rendermi conto del fatto che la mia implementazione di questo algoritmo fosse corretta oppure no. E quello che ho fatto io è andare a mettere su un grafico, diciamo, tenendo a mente il modo in cui opera l'algoritmo, il numero di celle che avevano assunto un valore definitivo per ogni iterazione, quindi il numero di celle collassate ad ogni iterazione. E quello che mi sono detta è che probabilmente, pensando un po' a come opera l'algoritmo, quello che avrei dovuto vedere sicuramente sarebbero stati degli scalini, che sono l'effetto della propagazione delle regole dopo ogni scelta, e poi un trend lineare tra questi scalini, perché se ad ogni iterazione l'algoritmo sceglie almeno definitivamente il valore di una cella, andando avanti io devo avere questo trend lineare, quindi non devo avere nessun plateau. Ho fatto una prima implementazione dell'algoritmo e ho ottenuto questa cosa qua. E chiaramente mi sono accorta che c'era decisamente qualcosa che non andava. Questo qualcosa che non va si vede tra la 151esima e la 251esima iterazione in cui c'è il plateau. Quindi evidentemente l'algoritmo non stava lavorando bene sullo step di propagazione. E poi un'altra cosa che non tornava è che c'erano troppe iterazioni, cioè per produrre una mappa 20x20 io mi ritrovavo ad avere per le mani 400 iterazioni che sono praticamente il risultato di aver considerato ogni singola cella, quindi non stava funzionando la propagazione. Allora ho messo a posto l'algoritmo e mi sono rifatta questa domanda mettendo sul grafico i risultati per una mappa 30x30 ed effettivamente il modo in cui operava poteva essere corretto perché in questa implementazione non ci sono plateau e soprattutto per scegliere i valori di 900 celle, dopo tutto ci aveva messo solamente 24 iterazioni, quindi la parte di propagazione sicuramente stava funzionando. Adesso una delle domande che è sorta spontaneamente sul gruppo di Python Italia, dopo che ho condiviso questi risultati, è quali sono le regole che potremmo chiamare sufficienti e insufficienti. Perdonatemi insomma la vaghezza della terminologia, adesso in un attimo vi spiego che cosa intendo. Cioè quali sono quelle regole che permettono di comporre una nuova mappa valida e quali no. Per poter fare questo studio, in realtà io sono passata alla logica proposizionale, quindi ho cercato di riformulare questo problema in un ambito di logica proposizionale, cioè ho provato a descrivere la mappa in termini di proposizioni logiche. E quindi prendendo spunto da Russell-Norvig ho cercato di fare questa cosa. La descrizione del problema in forma proposizionale in realtà non è stata semplicissima, questo perché la prima cosa che uno tende a fare è descrivere solamente le conseguenze positive, cioè tutto quello che deve conseguire da una scelta, ma tende a tralasciare tutto quello, di descrivere tutto quello che non può conseguire da una scelta, mentre invece entrambe le cose sono assolutamente importanti. E in questo ambito quindi le mappe valide sono solamente quelle definite dalle combinazioni di letterali per cui tutte le implicazioni sono vere. E chiaramente siccome risolvere questo problema a mano è molto complicato ed è molto complicato anche scrivere le regole, mi sono scritta sia un descrittore di regole proposizionali che analizzando l'immagine tirasse fuori tutte le regole e sia un fact checker per trovare le combinazioni di letterali per cui le mappe erano valide. Ok, per produrre le regole in realtà ho usato un po' di automazione SymPy, mi sono data dei simboli. Questa serie di formule può sembrare intimidente, è la descrizione di una mappa 1x2, in realtà dice delle cose che sono parecchio banali. In queste regole L sta per terra, perché è land, C sta per costa, coast, e S sta per mare, sea. In realtà, ad esempio, le prime due righe ci dicono che se mettiamo una costa in 0,0, allora possiamo avere sotto solamente un mare e non ci può essere una costa e non ci può essere una terra. Oppure la seconda riga ci dice che c'è una costa in 1,0 se e solo se sopra c'è una land e non c'è una costa e non c'è un mare, quindi esclude le altre due scelte. Mentre invece, ad esempio, le ultime due righe ci dicono che dobbiamo fare almeno una scelta per ognuna delle due celle. Per convincerci che le mappe, che le regole generano delle mappe valide, usiamo il fact checker, cioè questo programma che ci restituisce i modelli. E in questo caso i modelli sono due e li vedete là sopra. Ve li leggo e ve li interpreto. La prima riga ci dice che se collochiamo una terra in 0,0, allora in 1,0 possiamo collocare una costa o un'altra terra e produce le due mappe valide che vedete in basso in questa slide. La seconda riga invece ci dice che se collochiamo una costa o un mare in 0,0, allora sotto possiamo trovarci solamente un mare e produce questi due mondi che vedete in basso nella slide. Le regole ci permettono quindi di produrre 4 mappe 1x2, cioè colonna da 2 celle valide. Tra l'altro non importa qual è la cella che scegliamo per il primo collasso, perché qualsiasi scelta faremo arriveremo sempre a una soluzione valida. E i ragionamenti in questo caso seguono per propagazione. Questa invece è un esempio di mappa di esempio insufficiente. In realtà il perché sia così, a guardarla è abbastanza banale capirlo, perché non viene descritto nulla che stia sopra al surfista, né alla sua sinistra, né nulla che stia sotto al mare, né nulla che sia alla destra o sotto o sopra la barca. Quindi diciamo, non descrive tutte le cose che possono succedere. E infatti se compiliamo le regole per questa mappa e lanciamo il sat checker, c'è un solo modello, che è quella mappa stessa da cui siamo partiti, quindi non è sufficiente per generare delle altre mappe valide. E questo fatto dipende dal fatto che, diciamo, dal fatto che abbiamo in realtà delle regole proposizionali che sono molto molto strette, cioè hanno già decisi un sacco di valori e quindi non lasciano spazio ad altre interpretazioni. E tra l'altro per arrivare a quest'unica soluzione dobbiamo pure beccare uno di quei valori lì, diciamo di collassare uno di quei valori che sono cerchiati, perché altrimenti alla soluzione non ci arriviamo, a quest'unica soluzione non ci arriviamo algoritmicamente. Addirittura poi per le mappe 3x3 le regole indotte dalla mappa di esempio non sono assolutamente sufficienti e il problema non è risolvibile, quindi non si può generare una mappa 3x3 a partire da quelle regole proposizionali. Una volta che abbiamo i modelli possiamo pure fare lo step inverso, quindi passare dalle regole ai mondi. Questi sono 3 mondi generati a partire al contrario dalle regole proposizionali. Però insomma voi sapete meglio di me che fare il sat checking è un problema che è NP completo, perché non ci sono scorciatoie, dobbiamo considerare tutte le combinazioni di variabili e vagliarle. E in realtà però quello che è successo è che avendo descritto questo problema in termini proposizionali possiamo passare al quantum, quindi applicare un quantum twist e cercare di ridurre questa, diciamo, questa complessità in qualche modo. Adesso nell'ambito del quantum computing esiste un algoritmo che si chiama algoritmo di Grover, che si può applicare a un problema in forma normale congiuntiva. Senza entrare troppo nei dettagli perché sarebbe sicuramente abbastanza complicato, quello che succede è che questo algoritmo amplifica le soluzioni giuste tra tutte le combinazioni di quelle disponibili e attenua quelle che invece sono sbagliate. E una cosa parecchio interessante è che queste soluzioni ve le tira fuori in un tempo che è O di radice quadrata di n, dove n è la grandezza del dominio delle soluzioni in cui state cercando. Allora è importante vedere che tutto quello che state per dire, che tutto quello che state per vedere da questo momento in poi funziona a livello puramente teorico. Cioè probabilmente se lo portate su un vero calcolatore quantistico non va bene. Quindi la prima cosa che possiamo fare è cercare di riportare le formule proposizionali in forma normale congiuntiva. Lo facciamo con SymPy, che è una fantastica funzione 2CNF che lo fa per noi. E a questo punto quello che ho fatto io è cercare di applicare Grover in cloud. L'ambiente cloud non mi leggeva benissimo i nomi di variabili scritti così, quindi ho operato una piccola sostituzione con le lettere. Ho applicato Grover, quello che vedete qua non è nient'altro che il tutorial di Qiskit per applicare Grover, leggermente modificato per risolvere le regole proposizionali che gli ho dato in input, e quello che è venuto fuori è che l'algoritmo ha amplificato 2 stati. Adesso qua sono molto affollati, però io ve li ho riportati in chiaro in quest'altra slide. Sono gli stati che vengono fuori nello step 1. Rimappandoli indietro ai nomi delle variabili otteniamo 2 modelli amplificati, che sono i 2 modelli che ci generavano i 4 mondi qualche slide fa. Infatti, se diciamo, li riesplichiamo, otteniamo queste mappe, che sono di nuovo 4 mappe valide. E that's it.
Grazie mille Giuna, veramente ogni volta è un'avventura. C'è già una domanda per l'anno prossimo, già così a bruciapelo. Per caso te lo volevo fare alla fine, ma è la prima proprio che ci è arrivata. Hai già idee per l'anno prossimo?
No,
e poi torniamo al tema di quest'anno?
Non ancora, ma sono sicura che mi lascerò ispirare da qualcos'altro.
Qualcosa uscirà fuori. E in particolare c'è un'altra domanda. Scusami un attimo che si è girato. Che relazione esiste tra la dimensione minima della matrice di input e il numero di elementi? Non so se la domanda è qua in sala. Ok, ti passo il microfono se vuoi esplicitare qualcosa.
È più una domanda che parte dall'osservazione della matrice d'esempio. Mi viene da pensare che più è grande la matrice, più è possibile inferire delle regole, no? Più è piccola, meno è possibile tirare fuori delle regole. Allo stesso modo, all'aumentare gli elementi, complichi il numero di vincoli che vai a creare, quindi immagino che ci debba essere una sorta di relazione, no?
E per elementi intendi di scelte che puoi fare su ogni singola cella? Sì, chiaramente se ci pensi, anche riportandolo all'ambito proposizionale, vuol dire che avrai più simboli, no? Avrai più letterali da considerare nell'ambito di quella formula, quindi sì.
Ok, grazie.
Grazie mille. Mi chiedevo se c'erano altre domande qua in sala direttamente, nel caso qua, ok?
Perché pensi che non funzionerebbe l'algoritmo di Grover qui?
Perché io non sono un'esperta di quantum, mi sono interessata solamente
Siamo in due.
in ambito non professionale, quindi non ho, perché so che comunque sul vero processore quantistico entrano diciamo delle dinamiche di errore, per cui il numero di qubit che stai utilizzando e la profondità di diciamo il tempo di soluzione che ci vuole per risolvere le cose influenza negativamente questo errore. Quindi la probabilità nel considerare diciamo, le combinazioni di letterali possono essere influenzate da questo errore e quindi essere soggette...
Cioè, verrebbe più rumoroso, ma funzionerebbe lo stesso, questo che stai dicendo? La risposta che hai alla fine, no? Perché l'algoritmo di Grover è determinato, credo, quando hai 4 possibilità, cioè 4 risposte possibili, e diventa probabilistico a partire da 6, da 8 e così via, no?
Sì, non so bene, non so risponderti con cognizione, diciamo, di causa su questa cosa in maniera precisa, però so che comunque queste cose poi applicate su un vero processore quantistico hanno comunque delle limitazioni sul numero di qubit, sull'errore che viene introdotto, per cui non...
Io penso funzionerebbe, però vabbè, ti ripeto, siamo in due.
Sarebbe interessante provare.
Ma anche su un simulatore quantistico, no?
Beh, il simulatore però considera, credo sempre, cioè lo risolve sempre in modo classico, no? In ogni caso è una simulazione.
Io credo che faccia un sampling della funzione, cioè fa il quadrato della funzione d'onda e poi ti fa un sampling e poi lo ripete per un tot di volte e ti dà una risposta alla Monte Carlo.
Ero molto tentata di provare comunque in cloud magari questa cosa. Il problema è che il sorgente che hai visto è nato vecchio, tra virgolette, nel senso che l'ho implementato, l'ho lanciato in cloud una volta e poi ho cambiato il runtime dello Jupyter, quindi ha smesso di funzionare. Però effettivamente sì, sarebbe stata una delle cose che avrei provato, cioè di vedere come...
Grazie.
Grazie. C'è un follow-up se implementato in un ambiente non quantistico, quindi un po' un follow-up di questo. Qual è la complessità? Hai citato qualcosa che...
È comunque NP completo, quindi
rimane
devi
NP
considerare
completo.
tutte le combinazioni. Cioè non hai scorciatoie per arrivare alla soluzione.
E come ti è venuta l'idea per questo talk? Hai citato qualcosa all'inizio, non so se vuoi espandere un po' di più.
Sì, no, in realtà ero incuriosita un po' da questo tipo di immagini, ero incuriosita da Wave Function Collapse, che era insomma, avevo visto delle animazioni su come operava e mi era molto piaciuto, volevo provare a implementarlo. All'inizio in realtà non avevo considerato di metterci una parte quantum, è arrivata per caso dopo perché mi sono imbattuta in Grover, quindi ho provato ad applicare la formalizzazione che avevo fatto, in realtà cadeva perfettamente nell'ambito di soluzione di Grover, quindi l'ho applicato.
Per caso hai dei suggerimenti sul tuo processo di esplorazione? Quindi ti viene un'idea, applichi e cerchi di lasciate la parola. Qual è un po' un consiglio che magari dai a qualcuno?
Se vedo qualcosa che mi interessa, mi informo su come funziona, provo a reimplementarlo io, è anche un modo di mettermi alla prova, in realtà. Mi piace molto questo aspetto ludico verso me stessa, di dire ok, ci provo, non so se ci riuscirò, ma lo faccio. E mi piace molto l'idea di magari tentare di approcciare il tema formalizzandolo in maniera matematica oppure cercando di metterci sotto discipline che normalmente sarebbero magari più lontane da quella cosa.
Grazie, Giona ci ispira sempre, ci sprona a sperimentare. Io spero che tutti colgano l'occasione per essere ispirate e ispirati. C'è qualche altra domanda dalla sala? So che poi si avvicinerà qualcuno. Va bene, allora non so se è un messaggio finale da dare o se vuoi ricordare i tuoi contatti, dove possiamo trovarti all'inizio.
Parlato tantissimo.
Scusa.
Eccomi qua.
Dicevi che il codice poi
sì, è
troviamo
su
su
GitHub,
GitHub.
sì,
Si può andare poi su questo, su quale computer, una domanda era su quale computer l'hai girato? Un normale computer?
No, sì,
può...
tramite Qiskit, che è un framework.
Perfetto.
La parte classica chiaramente funziona da sé, l'algoritmo, qualsiasi PC è perfetto. La parte quantistica è stata sviluppata, cioè, insomma, in realtà è una variazione sul tema del tutorial dei problemi SAT di Qiskit. Quindi non ho fatto nient'altro che metterci le regole proposizionali che avevo trovato per il problema e quello insomma gira coerentemente con la disponibilità di Qiskit sui vari processori e con la disponibilità dei package che fanno questa cosa, che si possono utilizzare con quel sorgente per fare questa cosa su ogni singola macchina.
Quindi anche leggersi bene la documentazione su quello che si vuole andare a implementare potrebbe essere un buon consiglio. Grazie mille Giuna, come sempre.
In what sense? No, I'm going to EuroPython. Is that what you mean? Like in July? Yeah. Are you going?
I was there last year. I'm not sure about this year.
Okay.
My mom actually sure.
Right.
Okay, are you ready for your last talk before the keynote, actually? So is your last talk here at PyCon, so thank you for being here. Yay! Yay!
Finally.
So here with us, here's Rodrigo Girao Serrao. Okay, he has a great background in maths and also in education, and he's a great developer. As you see, 500 free days working full-time for free and open source software. And he's going to give us some very good tips about his experience, and eventually some tips for all of us as well, right?
Mm-hmm.
Okay, thank you.
Thanks.
The stage is yours.
Thank you. I don't know if they're going to be good tips. I have some tips, then you'll figure out if they're good or not. But before we get to those, there's this. Thank you. They're a bit late, but yeah, thank you. There's this obvious disclaimer. I thought it was an obvious disclaimer. I'm sharing my experience working 503 days on open source. It's my experience. The things I'm about to tell you, they only make sense under the context of my life, right? But apparently someone on the internet didn't get that. And so they complained and said, I mean, to me, these lessons feel very similar to the lessons learned working at a mid-sized company. Sure, and so I changed the name of my talk, but I couldn't change it here, but I changed it on the slides. So now it's 503 days working full-time on free and open source software. Lessons that I learned, I don't know it by heart. So it goes, lessons I learned, but that aren't necessarily unique to free and open source software, and that you might have learned, or might still learn, in some other personal or professional context, you know? So just keep that in mind, because I think it's important. So let's get to the lessons themselves, because hopefully in them you'll have some, even though it's subjective, maybe some things will apply to you in some form or another, hopefully. So we're going to be dividing the lessons in 4 broad categories or topics or whatever you want to call them. I forgot to start my timer already, so if I get late now, you know it's because the timer is not in sync. And so one category is going to be about getting a job in tech. The other category is going to be about managing your ego. Then we'll talk about interacting with users. And finally, we'll talk about working with large code bases that don't fit inside your head. So let's get started. Let's talk about getting a tech job. Now, there's a very interesting concept or a very interesting idea that probably you've all realized by now, but that is everything you do online acts as a banner for you. It's free publicity. It can be good publicity or bad publicity, but it's there. So if you want, well, make sure, try and not use it for bad publicity, but if you want, you can use it, you can try to use it for good publicity. So this job in particular, I found out about it from Twitter. And if I hadn't been on Twitter, or if I hadn't been active on Twitter talking about Python and sharing some Python tips, I probably wouldn't have gotten this job. So bear that in mind. The internet is a very good resource, so you can find some interesting opportunities there. And the other thing is that luck is not 100% random. There's a part of luck is random, but there's things you can do to increase your luck. And it's very easy to understand this, because I'll ask you this. Who's more likely to get lucky? The person that stays all day sitting, watching TV, or the person that gets out of the house, moves around, talks to people, is nice to people? Who's more likely to get lucky in some way or another? The person that moves and does things, right? You're more likely to meet someone that's interesting or that might help you in the future if you sit at a random table at PyCon with people you don't know. That's more likely to bring you luck than if you just sit alone in a corner where no one can even see you, right? So part of luck is completely random, and part of luck you can work for it, so you can increase the chances of getting lucky, all right? So I find this a very powerful idea.
I like, when people ask me what's my favorite quote, I always say that my favorite quote is, luck is what happens when opportunity meets preparation. I like this a lot. So this is about the non-random part of luck. So this is what I had to say about this area, this big area. Now I want to talk about managing your ego. And this is not about removing your ego, it's about keeping it in check. So just make sure that your ego doesn't get in the way of getting your job done. And again, this is personal. For many reasons, I have a very big ego. And I was told that when I was little, I was unbearable. So I apologize for that. I think I'm reasonable now. But so so let the record show that someone in the audience laughed when I said that now I'm bearable. Okay, so maybe not for Steve, but hopefully for other people, I'm bearable.
I laughed because I was the same at your age.
Okay, so now we understand each other. And so it's about managing your ego, making sure it doesn't get in the way, right? And the reason I'm saying this is because as soon as I joined the company, this wasn't a mid-sized company like the random internet person predicted or guessed. There was 4 of us. And when I joined, I was very well aware that I was going to be, for the first time in my life, I was going to be the worst Python programmer in the room. And don't worry, I was the best one before because I was the only one. So by definition, I was the best, right? So for the first time, I was going to be the worst Python programmer. And if, on the one hand, maybe that can hurt my ego a bit because I know that, and this is silly, but if it hurts because now I'm not the best, at the same time, it's perfect because if you're surrounded by people that can pull you up, that's when you learn the most, that's when you grow the most. So I knew I had to take this opportunity to learn as much as I could. And so one thing I realized I needed to do was to ask all of the questions. If I have a question, I have to ask. These 3 programmers, they're just a message away, and they're working with me, and sadly for them, they have to interact with me, so I'll just use this opportunity. And one other thing, and in particular when situation when this was very important, was in code reviews, right? Code reviews. Because if you think about it, in programming, I don't think there's many jobs where this is true. But in programming, it's not only about getting the job done, it's also about how you got the job done. So it's not only whether the code does what it's supposed to do, it's also about the code itself. That's what code reviews are for. It's both to check that the code does what it is supposed to do and to make sure that it's, I don't know, understandable, readable, maintainable, future-proof, whatever, right? So it's about the code as well. And therefore, when people reviewed my code, when my colleagues reviewed my code, if they said, well, Rodrigo, maybe you want to change this, or maybe you want to change that, I knew I needed to ask, but why? And not in a self-centered or self-assured or very narcissistic kind of way because I know what I did is the best way possible and you don't know what you're talking about. No, in a very honest way. Why? Please teach me because next time I want to be able to do it the right way on the first try. Let's not waste our time. Sorry, English is difficult. I only know Python. So that was it. And the reverse is also true. If people are writing code and if I get to review their code, if something doesn't make sense or if something looks new to me or if there's a new construct or a new method or whatever, I can ask why. You know, they can help me learn. And one other thing is, even if you feel like you're working with people that are better than you, sometimes they'll miss things. So even if I think I see something I think it's obvious, I feel like this is the obvious way to do it. But my colleagues, they're not Dutch, so maybe they missed it. And so I'll ask, why didn't you do it this way? And then one of 2 things typically happens. Sometimes they'll say, well, as I was working on this, I spent some time thinking about it, and I realized that this simpler approach might have other repercussions down the way. And so then they justify their choice. And on top of it, now there's a written record of why we didn't go that way. Or, if I get lucky, they just missed it, and then I made a good contribution. So ask all of the questions, all of the time. I think that's a very important thing. One thing I like, I've heard many intelligent people say this, intelligence is not being afraid of asking questions. Or it's not, you don't, if you ask them questions, quote unquote, you're not stupid because of that. Intelligent people are not afraid of asking questions. No, I'm not saying I'm intelligent. I'm just saying that I ask questions, right? So it's, be careful with the way the implications go. And then, along with the ask questions, embrace the feedback. If people are suggesting things, if they're asking for changes, or if they're asking their own questions, I have to be open to a dialogue and explain my reasoning, or be open to better suggestions if my goal is to grow. And I was trying to do that. I was trying to learn, so this was my mindset. If you want to do something else, maybe you don't want this mindset, but I think it's useful. And now I'll show you something interesting. Just let's laugh a bit. So the project I was working on was this textual project. It lets you build these interfaces inside the terminal. So all of these are terminal windows with the calculator and the code, not editor, but the code preview and the table and some things. So I was working on this. And one of my early PRs, one of my early pull requests, was greeted with this request changes, this ominous thing that told me I missed something. And you would have hoped that as time went by, I would get better, right? And in here, Will just has one request for me. And a couple of PRs later, now Will has a few requests. And it just keeps getting better. As I do more pull requests and I get more changes requested. And then it just feels like I nailed it, right? Dave approved my changes. But then Will butted in and said, no, we need to work on this. But it's actually, and it's just part of the process. You get plenty of pull request changes. And again, this is maybe the other side of the coin of, if I weren't making any pull requests, I would have gotten 0 changes requested, right? If I did 0, then everything I did was perfect. If I'm working, obviously I'll be making mistakes. And I'm showing you my side of the coin, but obviously my colleagues, they also have these changes, these request changes, or they have. Can we switch to Portuguese? Maybe it's easier. I also asked them to change things. I asked Will to change things and my other colleagues. And it's part of the process, right? Because everyone makes mistakes. And it's everyone has said it, everyone has heard 10, 20, 30 people say it, but I still, I felt it. I felt how useful this sentence is. Everyone makes mistakes. And it's reassuring because I made plenty, right? The only thing you need to make sure is that you don't make the same mistake twice. Making the same mistake twice, that's dodgy. But if you keep it to unique mistakes, if you're creative enough to only make different mistakes, then that's good. And I'll show you, I was not brave enough to include the full issue, but this was the worst issue I ever opened in my life. And I'll boil it down, I'm stripping away some context, but it was essentially something like bug report. If you run Python, Python runs. This doesn't look good. If you strip away the context, that's more or less what I said. Literally, I said, if I run Python, Python runs. It was a bit ridiculous. And Dave, I stripped it, but Dave just said, well, if Python runs, don't you expect it to run? And then it struck me, yeah, of course. So let's just pretend that this didn't happen. I mean, it was the low point of my career, I'll tell you that. But it was handled with grace. My colleagues handled it with grace. And this was a bit ridiculous, but thankfully we only wasted 5 minutes of Dave's time. I've made other PRs that wasted a bit more than 5 minutes of my colleagues' time.
You thumbed up it.
Somewhat? I didn't, sorry, what?
Who gave it the thumbs up?
Oh, it was Dave, I think. I think Dave gave me the thumbs up. So Dave was all in for the shameful label. Thankfully, we didn't create it. So it was silly. It was a silly blunder, but it wasn't terrible. And I've made a couple of worse blunders, and they were all met with the same grace. And that told me 2 things. So first was I was working with apparently decent human beings, so that was good. And second, no, it was just it, essentially. It helped me understand, so if you make a mistake and people around you are mean to you, maybe you're not in the right place. I don't know. It's going to depend, but likely you're not in the right place. And thankfully, when I made some blunders, people were nice to me. People explained what was wrong and why it was wrong. And that was good, because when others made blunders, probably not as severe as mine, but when others made blunders, I was also nice to them because I understood. I mean, everyone makes mistakes, right? The thing that everyone knows. Now let's talk about the greatest problem of an open source project: users. How do you interact with users online? How do you interact with people you've never met through text online? Well, I took a bit of time to realize this, but this might be the best tip I have for you. Please create a contributing guide. Please create one. It's going to protect you. It's going to have your back in all sorts of different situations. So if you have an open source project, and if you don't have a contributing guide, create one. It's very useful for others and for yourself as well. And now let's focus on why this was good for me, right? And also, disclaimer, no one will read it at first, but it's still important because it's the fact that it exists that it's going to be important, that is going to be important. So one thing you can do is to help people contribute and to make everyone's lives easier is give clear instructions to people that want to report bugs. And if you use GitHub, there's this very good feature that you can create issue templates. And so what that means is that when someone clicks new issue, they're greeted with something like this, where they will have as many options as you've provided. And in particular, for example, if we went ahead and created this get started for the bug report, the issue is going to be pre-filled with information which you should obviously adapt to your own project, and it should include instructions that are useful to the bug reporters. For example, in the textual case, you saw the terminal with the things, right, with the text inputs and the buttons and whatever. So that's running in the terminal. And so for us, when someone opens a bug report, it's often useful to know what's the terminal that people are using, what were the settings. And we gave those instructions, because it's not obvious that you should include that information, we gave those instructions in the bug report. And so that's something that you should do. It's almost free because you do it once and then it gets used as many times as people open bugs. So I think that's very important. So help bug reporters help you. And one thing that you might do in your instructions is refer to the contributing guide. All right, so I've advanced 5 slides maybe, and the contributing guide is already being helpful. So you can refer to it because you can give a more detailed explanation of how you should go about X, Y, Z in that guide. Another thing that I think is very important, and not everyone will agree with me, and I've met people who disagree, and that's fine, my opinion, you should be so kind it's annoying. In your interactions, you should be ridiculously kind, I think. Just stay kind, be kind at all times. And one thing that helped me, or that helps me go through this process, is when someone interacts in a way that doesn't seem to be kind, I try to create these very weird scenarios in my head that justify their behavior. For example, if someone types in a not so nice way, I'll think, well, maybe they're not native English speakers and maybe they got the words wrong, or something like that. Because sometimes it's actually true, and even if it's not, if you believe in it hard enough, it's going to be fine. If this doesn't work for you, I learned another interesting strategy, which is exponential backoff. So if you do an interaction, this is a proper algorithm in maybe networking or something, I think. You have an interaction that's not so nice, you go away for 5 minutes before replying, you reply. The reply is not so nice, you go away for 10 minutes, you come back. The reply is not so nice, you go away for whatever. And you can obviously use the factor that you prefer. I was doubling the time, maybe you want to go 10 times. So 10 minutes, then 100 minutes, whatever works for you. So exponential backoff apparently works in real life with humans too. That's a tip for you. So that's one thing. Another thing about being so kind it's annoying is I think it's important to give your first reply to an interaction as quickly as possible. So if someone opens a pull request or an issue, I think your first reply should be as soon as possible. Even if it's a huge pull request you can't review right away, even if it's a huge bug report that doesn't look right or whatever. Your first reply should be quick. And if you're busy, which you probably are, that's fine. You just say, thank you for your time. I'll get back to this as soon as possible. And I think it's enough. It's enough because it tells the person that spent their time opening the issue or the pull request, it tells them, okay, I've been seen, I've been acknowledged, and I understand that this person has a lot to do, and they'll get to me when possible. Because there's nothing, because to me, and again, subjective, to me it upsets me when I open an issue and it goes months without a reply. I'm not saying a resolution, I mean a reply, as in it just fell through the void. And then you see the person being active in that repo, in other repos, and I can't help but feel a little bit hurt. And so this first reply, I think, is very important. Now, when you go about giving your first reply, if you spot something that's already missing, don't put too much work into it. Just refer people to the contributing guide. So again, second time the contributing guide helps us. If there's obvious steps missing, link to it. Or maybe just say, well, thank you, I'm busy now. Please make sure you go through all of the steps in the contributing guide. So just, again, you invested in it once, it just keeps bearing fruit. Very important, I think. And now it's my other way of thinking about this, of giving this first reply quickly, a justification if you don't like the human approach of let's be kind to each other because kindness brings kindness. If that doesn't work with you, let me put it this way. Someone spent their time interacting with your software, with your project, and it's likely that there's something in it for you. You probably stand to gain something. So you don't want to alienate the person that interacted with you. So reply to them. Okay? So if the human approach, if the sensible approach doesn't work for you, then you have a justification now. It's transactional, or you can think of it as being transactional. Now this is my favorite part. Handling external pull requests. I'm not very confrontational. Or if I can, if there's another reasonable way to get to the outcome I think is the best one, I will avoid confrontations. Not in a I'll sneak through the back door kind of way. No, just there's typically different ways of handling things, and if I can, I will not fight with someone. Because why would I? I don't know, I don't like it. But sometimes it can be difficult. I've heard insane stories of all sorts of weird interactions. Thankfully, I haven't had many weird interactions, but these things can be difficult. And so imagine you have someone opens a pull request out of the blue, and they're very enthusiastic. They're, I don't know, implementing a feature they really want there. But maybe the way they designed the feature doesn't really align with what you've done. Well, maybe you can refer to the contributing guide and say, well, as per the contributing guide, we prefer to have issues first so that we can discuss design and then we implement things. So instead of me having to go there, walk up to a random person and say, well, yes, but no, I can just say, look, there's this document that you should have read, and if you don't mind, please refer to it because we will want to talk about what you've done here. And so this helps me because it's something else that's kind of protecting me. Or maybe someone, they've opened the issue, we've discussed things, or there's a bug report, they followed the instructions, and they opened the pull request, but then for some reason, there were hundreds of files with all of the docstrings following exactly the same convention. But they decided their docstring doesn't need to follow the convention, or maybe their code doesn't need a docstring, or, you know, just, again, I think some things are obvious because all of the code looks the same, and their code doesn't. And instead of you having to step up and say, well, I'm sorry for being picky, but in this project, we really only use 5-letter variable names, so could you please change it? Because the other person might perceive that as being picky or annoying or just whatever. You can refer to the contributing guide. because your contributing guide should have all of these, right? Follow this standard for docstrings. Variable names follow this thing. We name files in this way, right? So I think it's the 4th time the contributing guide saved us. And again, these are just categories of interactions, because you might have plenty of different interactions like this. And now, if this was my favorite overall thing, let me tell you about my most favorite thing of external pull requests, which is closing them. I love it. I love it. As someone who doesn't like confrontation, this is perfect. Just go to someone random and say, yes, but no. It's excellent. And so I'll tell you a story. This happened to me, and this story was what made me understand that the contributing guide was very important. So if I had the contributing guide, I wouldn't have this story to share. Essentially, someone opened a pull request spontaneously to improve the documentation. Now, the documentation is written text, and written text tends to be subjective. And the author of the pull request was obviously with their best, I need to say these things because the author is in this room. But the author was obviously with their best intentions wanting to improve the documentation. But I didn't necessarily agree with all of the changes. And so I checked with my team, and they also didn't agree with some of the changes. And so essentially we had to close the pull request because it was going to change the documentation into a style that wasn't ours, it wasn't our preferred style, and we didn't think it was for the best. And so when you have to do this, when you have to close a pull request, one thing that I like to try to do is look for things that are salvageable, look for things that are, even if it's a small bit, look for it, and open a second pull request, add the original author as a co-author, and merge that, so that when you close the pull request, you can say, look, this isn't how we wanted to go about this or whatever. We took these parts that were good, we liked these, we opened this other pull request, you can link to it, and we added you as a co-author. Now, depending on how long you've been doing this, and depending on the way your brain is wired, adding the other person as a co-author might sound stupid, silly, extra work. I think it's very important for multiple reasons, but one example is someone very enthusiastic about open source just came from their first PyCon ever. They just came out of PyCon Italia. They attended my talk. They attended Stephanie's talk. They attended Paolo's talk. Open source is awesome. Let's contribute. Everyone's in it to win it. It's good for everyone, and they want to contribute. And then, bam, the pull request is closed. And then there was, a second after, there was another pull request that was uncannily similar that was merged. And they feel like, yeah, well, thanks, because they feel like their work wasn't acknowledged. And so adding the co-author, I think, is good for the person because they see, okay, I did something. Maybe not everything was useful, but I helped. So that's one thing. Try to think if you can save something. And then to top it all off, so remember I had to close this PR, right? And this was my first time closing because if you're just trying to fix a typo, you just close it. A typo is a small thing. If you have to close it, it's no big deal. But this person had spent some time working on it. And I had to close it. It was my first time closing a non-trivial pull request. And so I wrote this big paragraph saying, I'm sorry, but this doesn't go with the way we think documentation should be written, blah, blah, blah. And then, so the blah, blah, blah. When I wrote it, I meant it. But I'm not going to say everything. I'm not a native English speaker. And so I tripped on a false friend. I don't know if you've heard this concept, but false friends are words that are very similar. They sound similar in two different languages, but they mean two different things. A very fun one between Portuguese and English is constipated. So in Portuguese, to be constipated, well, the thing that looks similar, eu estou constipado, I'm saying that I have a cold. And so you can imagine little kids walking up to the teachers and saying, I'm constipated, for example. This happens a lot. So this is an example of a false friend. It wasn't the one I tripped into. But essentially, I was trying to be apologetic for closing the PR, and I managed to insult the author. So that was interesting. And thankfully, both the author was nice about it, but I managed to edit the issue because Will, so the guy that was one of the guys that was working with me, said, well, Rodrigo, I don't think you want to use that word. And so I looked it up, and definitely wasn't the word I was looking for. That was fixed. Now we're friends, so everything's fine. So that's it. Now let's talk about working on a big code base. And big depends on you. But for me, I was working on a very big code base. I couldn't keep all of the details inside my head. I didn't know how everything worked. There's files I have never opened yet. There's things I have no idea how they work. There's things I kind of have an idea, and there's things I understand. So how do you work on such a big project? Whenever I had to write code, there were 4 things I always kept in mind. And this was especially relevant when I was implementing features, but also when you're fixing bugs. So the 4 things, the Zen of Rodrigo. What were they? Well, I should always think what's best for the developer, the one that's going to use the code I'm writing. It's not what's best for me, because thankfully I'm being paid to write this, to work on this. It's the other people that will come along, what's best for them. So this was important. The next one is, what's the spirit of the issue I'm trying to fix? It's not what's written in it, it's what's the spirit. And this is difficult for me because I studied mathematics. And in mathematics, things are well defined. It either is or isn't. So issues didn't happen to be like this most of the time. For example, this is a good example. Take a look at this tweet. Someone said, here's some input, here's some output, write a function that converts the input to the output. Think about it for a second. Yeah? Here's the mathematician's answer. Right? As per the instructions, my function produces the correct output given this input. This is correct. But this is probably not the spirit of the tweet. Now, obviously, I also very conveniently removed some context from here. So this is not the spirit. And so for me, it was a big hurdle to sit down, look at an issue, read it, and then read between the lines. So reading the lines is already hard. Reading between the lines, that was a completely out of this world task. So very important. Think about the spirit. What's the point? Why was this written down? Why do I need to do this? The third point, I take the hit so that the developer doesn't. Annoying edge case, I don't care. I have to write it. Is it a very difficult task? I don't care. My boss doesn't care. I have to write it. Right? It's me. I have to take the hit so that it's easy for the people that will come along. And finally, I was very good at doing this the other way around. Am I preventing something reasonable from happening in the future? With my implementation, am I restricting behavior that might conceivably be helpful in the future? Maybe it's not in the spec, but are my choices now clearly blocking something that might come later? So that was a very interesting exercise for me. Think about this. To have to think about this. Another thing that I found very helpful was to take notes. So whenever I had to fight a bug, I would have to go deep into the weeds. I would have to figure out how things were working, where things were coming from. It was not always trivial. It usually wasn't trivial. And so one thing that helped me learn more about the code base as I went along was to take notes of some of the things I found, some of the interactions I finally understood, because later down the road, sometimes I would encounter a bug that was similar, and so my notes would help. Sometimes I would encounter a bug that was completely different, but the knowledge I had from this other bug was helpful, and the fact that I was writing notes was helping commit this to memory, and it also served as a reference that I could check later. Personally, I wrote them down. Maybe you want to record them with your voice, or you want to make drawings, or something that works for you. I wrote them down. And finally, an important thing that I found out about working on this big, large code base, and that I developed, was my personal pull request checklist. And I'll walk you through it, because I think this is one of the least subjective parts of this talk. So I think this is objectively helpful to the majority. So it all started with me reading an issue and writing some code to fix the issue. And after I've written some code, I need to ask myself, have I fixed the whole issue? Have I fixed the whole thing? Because sometimes I wouldn't. For some reason, I was very good at forgetting half of the issue. So make sure that I fix the whole thing. If I didn't, I would go back to the beginning. Let me reread the issue and write code to fix it. And if I had, I would run the tests. Just to make sure that I didn't break something on the other side of the code. Because the code base was so big that sometimes fixing something here would break something seemingly completely unrelated elsewhere. So running the tests for me was very helpful. And so I would run the tests. And after running them, I would run them again for good measure, just to make sure. So the next thing you do is you ask yourself, did I clean the prints I used to debug? Did I remove the imports that I no longer need? Did I remove random comments that I inserted as I was testing hypotheses? Because if I didn't, which was also fairly common, I would have to remove them and then run the tests. And if I had done that, I would just run the tests again, just to make sure that they were passing. So now the code is supposedly in a good state. What I'll do next is, right before pushing the pull request or pushing my branch to the origin, to the master repo, I would think to myself, I would ask myself, was running the tests the very last thing that I did? And if it looks like I'm being obsessive about the tests, it's because I am, but also because I broke tests in so many weird ways. Fixing typos, how can I break the tests by fixing typos? How can I break the tests by deleting unnecessary imports? If you can imagine it, I did it. And so I ran the tests one last time, and then I made the pull request. And if you want, you can take a picture, because I think this is my greatest gift to you, is this pull request checklist. And what I did next, and apparently this was actually helpful for me, was I opened the pull request in draft, as a draft, and I would review the pull request myself. Most of the time, I would find something I had missed. So I would review the pull request myself, make sure I was happy with it, make sure that CI passed, and only then I would request a review. So the idea here was that I was reducing the time that others have to spend going through my code. To put it all together, if we think about the four big areas, the four big topics that we've covered, let's boil it down to four interesting things you can take home with you. So the first one is, remember that everything you do online acts as a banner, so either use that as your advantage or make sure that's not a disadvantage. The next thing is, be open to learning. Ask questions and make sure that you accept all of the feedback, and everything that's shared with you, make sure you accept it openly. Be kind with others, and make sure to add a contributing guide. It's going to save you, it's going to help you, it's got your back. And finally, run the tests. Just run them, please. One thing, this was supposed to be a non-technical talk. From a technical point of view, having tests was so helpful. So make sure you write some tests, because for me, it gave me confidence in my changes. Obviously, I would still introduce bugs, because that's what developers do, right? We introduce bugs. But it helped. It helped. Thank you for your time. Of these 4 things, I do 3, I eat 1. It's up to you to figure out which is which. And this QR code will take you to my website if you want to get in touch or check the things I've written. Thank you.
Thank you very much, Rodrigo. We learn a lot, and we wish that we apply as well these
Hopefully,
lessons.
yes.
So one of your main point was to ask questions. So
Yes.
we have some questions for
Excellent,
you.
excellent.
First of all, a quick question. Do you have template or known one to create contribution guide from scratch?
I don't have a preferred template. What I would suggest is open a couple of your favorite projects, take a look at their contributing guides, and steal the best parts. Borrow the best parts. Yes. Steal them straight
like
away.
an artist.
Exactly.
About documentation also, how often do you happen that you need to update the reference guide due to stress, in quotes, with users on pull request or issue?
I'm not sure I understood the question.
So, please, is the question in the room? Okay, I can give you, if you want to expand.
Like if the contributing guide was not enough or didn't cover any specific case that you're having like stress with users in discussions on pull requests and issues, like it is a situation when the contributing guide is not helping you as you would expect, because you referred a lot to the contributing guide as a shield, and it's not actually shielding you, so there's a corner case like the tests where it's not actually helping you so much. Do you end up updating the contributing guide just to cover that corner case, or what do you do?
I don't, off the top of my head, I don't remember any specific situations like that. What I tend to do in life is, if it's a one-off, I'll just do it myself. The second time it shows up, it's worth jotting it down for others. So maybe I would use this rule of thumb to go about handling those situations. Yeah.
There was also a question about UX, just asking if this was from the room as well, or I'm going to ask you. So any tips regarding, oh, sorry?
I think it was Vinicius as well.
Ah, okay, yeah, please go ahead.
You can see if you get the question, let's see if I stress you out.
No,
I'm already stressed out, what do you mean? Yes.
No, any tips regarding user experience, UXE? The company does dog fooding sessions, or how to ensure the users having a great UXE experience, UX experience?
The best way to ensure that the user has a great user experience is to either not have any users or don't ask what they think. But because we couldn't do either of that, we did have weeks where we would dog feed ourselves. I think that's the expression you used, right? We would just play around with the framework, see if we could build something out of it. It helped a bit, but asking the users is always the best thing, because even if you're dog feeding yourself, you are the one building it. So you probably know your way around it, and sometimes you don't understand that something is a quirk, because to you it feels natural. Yeah, but we did do some dog feeding, yeah.
Thank you. A question, what's your approach? Is it a benefit if free open source software project as a BDFL, so benevolent dictator for life, or if so, why? So how strict perhaps have to be the rules to be followed, or who takes the decisions, if it's needed or not?
I'm not good with philosophical questions.
Okay.
So I'll avoid the question by saying something else that I think is interesting, which
Please reframe it as you wish.
Exactly. So let's ignore the question and let's pretend that I was asked something similar but different. Just because you have an open source project, it doesn't mean you want to handle the burden of having contributors or handling all of those interactions. So it's fair game. I think it's fair game to say, this is here for anyone to use. I'm not interested in new features. Or I'm only interested in security bug reports. I think that's fair game. And so I think this is the answer to my made-up question in my head. If it's your project, you can go about it. You can be if you're always kind, I think you can be as authoritarian as you want. I mean, if you don't want the feature, you don't want the feature. And if your contributing guide says, please open an issue first, then if the person opens an issue, suggests a feature, and you don't want it, you can say, well, thank you, but I'm not interested in it. And if it's open source, maybe the person can fork it and implement it themselves. I mean, why not? It's your project. If you want to shape it the way you want to, it's your right to do so.
Yeah, thank you. Do I agree? Keeping the focus on the clarity and the kindness, as you mentioned, also in different points. Yeah. Okay, I don't know if there is a very last question here from the room live. Here, oh wow, free. So let's go for this free. You can choose one because they are quite.
I can't do that. Otherwise, I'll be in.
No, please, let's go just from in order.
Okay, mine's going to be super quick. Did you not run tests on the pull request? Is that why you had to run them locally before creating the pull request?
What, sorry?
Did you not run tests on the pull request? Because you mentioned that you had to run tests multiple times before opening the pull request.
Yes, I did run tests locally.
Yeah.
But I don't want, GitHub Actions is much slower than my computer, so I just run them locally before spending. Yeah, unless
Okay,
I want to
that makes
stall.
sense.
If I want to stall, yeah.
Hi, you probably don't remember it, but just in case, have you ever heard of egoless programming? It was something that became popular in the 1970s, and that basically, that was where I learned that it's about the code, it's not about you.
Oh, so you said egoless.
Egoless, yeah. Do a
Right,
search for egoless programming. It was a
Egoless programming.
thing 50 years ago.
Okay, thank you.
I think good things came up to the surface again.
Yeah.
Yes, very last questions?
Thank you. We've been saying you, and I don't know whether you meant you singular or you plural, because I'm wondering how this scales when you're addressing, for example, a team or a company of 1,000 people, and how they might implement all of these ideas and principles.
Yes. So, there were 4 of us. I don't know how this scales. I'm sorry. You give it a go, and then you let me know. I don't know. There's some things scale well. Being kind scales well, I think, right? Or no? Don't you think? I don't know.
It's difficult to teach one person to be kind, but teaching 1,000? It's hard.
Right.
Let's be a force for kindness. I love to end this session like that. Okay, a big round of applause for Rodrigo.
Thank you.
Now, please enjoy your last coffee breaks for PyCon, and be sure to be at 5 at the main keynote room. Thank you.